Summer. I. Summer. I. Summer. I. Summer.
Wait, hold on. Stop the music. Stop the music. Stop the music. Stop the music. Never ends. Wait a minute. What? The live? What? Oh, that was quick. Huh. Great stream, bro. All right. Excellent. All right. All right. Yeah. All right. Let's fix the screen. We have fixed the screen. Good morning. How's everybody doing? Today is Friday in California. Shoot. Anyway, is Titan with you today? No. He is not. He is not. We've got bamboozled by the SpaceX. And I have the coffee brewing. I got to go get the coffee. So there was supposed to be a Starlink launch today. The Starlink launch was supposed to be at 8:30 or 8:13 this morning, I think it was. It got postponed to now. It should have been right like. It got postponed to like right now, and it's ghosts, ghosts, ghosts. Period, question mark. What was I saying? Yeah, it would have gotten postponed to right now, and they scrubbed it because recovery conditions out in the Atlantic were not good. All I can say is, frick you, Debbie! Now this looks like a lunch to me, so everybody just let me eat, because I need a little pork and beef, because I feel so empty without meat. No? It's the hurricane. It's the tropical storm Debbie. Tropical storm Debbie. No? What do you mean no? That was a good rhyme. Because I need a little pork and beef, because I feel so empty without meat. No? Marshall, I'm on the way. Guess who's back? Back again. No? All right, fine. 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 Stop that. Yep. No. I don't want to.
Discovery, go at throttle up.
I need to go get coffee. I need to go get coffee. So there was supposed to be a launch, but there isn't now. So we're going to play Kerbal. So I'm loading up Kerbal and I'm going to get my coffee. That's what I'm doing. That is what I'm doing, because I just said it. So what's the plan for today's stream? So first of all, APOC, where have you been, dude? So guys, over in the YouTube chat, there's a viewer over there that, if you don't know, that I think started watching the stream in probably like 2014 or something, 2013, 2014. He's over there. He's over there. So if you hear me talking to APOC over there, that's what's going on. It's been a long time, dude. Hope everything is well. What have you been doing? What the hell you been doing this whole time? I've been just sitting here in my control room for like years. It's fine. It's fine. It's fine. Yeah, 2013 at least, dude. It's been a long time. It's been a long time, been a long time, been a long, lonely time. I'm going to get my coffee. Somebody get me some coffee. Tonight on Miami Vice, Crockett gets the boss some coffee. So, what's on the docket for the day? Why not going to mention getting married, a house, or a dog? I'm getting to it. I'm doing great, working away, keeping busy. All right, so, APOC, the last time I think you watched this stream, I don't even think I was in the apartment yet. So I have a wife, I have a dog, a house with a white picket fence. We're really making it. We're really moving up in the world. Look at this. I got a garage, a full shop in my backyard, complete with clapped out car that's disassembled. That's not the red truck. It's not the red truck. The red truck actually runs just fine. I fixed it. It's good to go. But here, you want to see something cool, man? Watch this. Watch this, right? It's like Wonka vision. Ready? I even have my own grass that I can touch. I love that truck. Thanks, Mike. It is a 59 F100. It runs great, actually. So I'm just going to sit here and pretend that my office door didn't just open for no reason. I'm just going to sit here and pretend that that was just the wind, even though it definitely looks like something just pushed that door open. Ghosts. 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 Period, question mark. I'm proud of you, man. You've come a long way. Thanks, man. Thank you. Oh, okay. So that's what I've been up to, APOC. Or Mark Pock. The ghosts leave you alone if you pretend they don't exist. Yep. Yeah, a lot has happened, dude. But it's good to see you, man. Thanks for checking up. Means a lot. From Boston to Cape Cod is a long way. Yeah, I don't live in Boston anymore. I moved to the Cape. It's just the wrong Cape. It's not Cape Canaveral, I mean. Hey, you gotta do what you gotta do. Okay. Love to see you doing well. Hey, anyway. Yeah, man, it's good to see you. Cool Mustang. Mustang. Can you see out the door or something? Like, can you see out the door? I'm confused. There is a Mustang out there, Brian, but that's not what that white car is. That white car is a Camaro. It's the competitor Mustang, an inferior product. Well, we're making it better. See all this stuff that I took out of it? Yeah, we put better stuff in. Like a coil over. See that? Isn't that nice? Hey, Jim Boy, what's going on? Dudes, real quick, while we kind of get into the groove here. You guys, anybody here watch Old Cleater? The video that he put out, that the Cleaters boys put out, is amazing. It's really cool. Hold on. Let me show you. Here we go. I mean, I don't want to watch the whole video out of respect. You know what I mean? This is in editorial context only. They have they're taking this NASCAR style truck and making it 4-wheel drive. And check this out. He has a fabricator. The fabricator's named Ty, and he's look at it. Look, oh, dude. He makes a frame from CNC cut brackets, which is just that's super freaking cool, dude. I think so, Hillness, yeah. They're making it all-wheel drive, dude. And this video had like a whole montage of his fabricator. His name's Ty. I actually got to meet him at the New England 900. It was real quick. I just said hi, but dude, he made a subframe out of CNC cut brackets. Dude, that is badass, dude. That's the kind of stuff that I really want to look to do with cars. It's sick. So you guys, I mean, you guys would dig it. Like, I didn't really don't like say like, oh, you know, space guys watch this, but dude, he laser scanned a stock F-150 frame, right? Laser scanned it, which I'm pretty sure that's an Xbox Connect, right? Also, that Mustang is sick. So he laser scanned it, brought it into Fusion 360, and, you know, made brackets, and then had them CNC cut, which is baller. And then, you know, the dude welded them all up, and then he went about putting the truck's on a chassis jig, right? And then he went about grafting this subframe that he freaking made to the chassis of the truck, which is so freaking cool, dude. Using console equipment to do it makes it even cooler, right? Dude, that is sick. And here, check this out. Like, I don't want to show too much because out of respect, you know what I mean? Because I don't know Cleater, but He's talking about the spindles there. Guy made a parallel four link suspension for, and look, that's what the subframe is for. A front diff. Holy crap. That's really freaking cool, man. That's awesome. That's like Kraken tech in real life. That's sick. I think that's super freaking cool. Yeah. So you guys want some pretty gnarly fabrication work, which fabrication work is like the equivalent of like Kraken teching something in KSP. It scratches the same itch for me. I don't know about you guys. Dude, that's badass, man. That's ridiculous. I know, dude. It's so good. I had to tell people about it. Go and watch the video. It's awesome. It's really, really, really freaking good, dude. That's some really nice work. Like, really nice work. That's actually nuts. Raptor 3 firing. Oh, yeah. Oh, yeah. Yeah. We got pictures of Raptor 3 going. What'd you think about Keg Rocket? Oh, I think Keg Rocket's cool. Also, Mike, that guy's a wrench too. Keg Rocket, you notice his Mustang in the background? He's got a first-gen Mustang sitting in the background of all his pictures of Keg Rocket. That's the kind of guy I want to go have beers with. Not out of the keg, though. We don't need to have that. Hey, Upsalot, what's up? That's a lot of deflection, goalie. All right. Where's your Keg Rocket? I don't know how to make one. Let me get more proficient with that welder, and then I'll get back to you on that. I got it. Dude, we got to get the TIG. We got to TIG. We got to learn how to TIG. I have to do it. I have to do a stream on a weekend or something, or I'm just sitting here trying to figure that out. I got to get a cup, and we have to get the pedal. My welder has the provisions for it, but I don't have any of the accoutrement. What the heck is that? Does a Keg Rocket run on beer? No. There's a guy on X that is a high-powered rocketry enthusiast, and I'm pretty sure the guy's a rocket scientist too, but here, I'll show you guys. This is sick. He's making a liquid fuel rocket out of kegs. He's making a liquid fuel rocket that uses kegs as a fuel and oxidizer. That's awesome. It's so good. See the Mustang? See what I'm talking about? It's so good, man. I love it. Hey, Dax, what's going on? Just finished an Artemis 2 style mission in KSP, and it flies so good. Also, is that Lockheed Martin concept lander from like 4 years ago is canceled? Or is it alive or half dead? Because I love that thing. That sounds like MADV. I don't know what's going on with MADV. Yeah. What? What is that doing there? I am very confused. What is that doing there? No. That should be on a rocket. Why? Oh. I would not, guys, I like sports. I do. I really do. I like sports. I played a lot of sports when I was growing up. I'd be all over this. I don't give a frick. I don't care about the soccer game, whatever. Yeah, I'm wondering what's going on there, but also, there's only 3 of those. They only made 3. What? What? Yeah. I mean, the Lunar Lander. I love MEDV too, but that thing is cool as well. Gonna send a link. It's from 2018. All right. That J2X is apparently the one from the U.S. Space and Rocket Center. Oh, the Lunar Lander concept. That was a proposed thing, Dax. It's that Lockheed Martin Lunar Lander is a Centaur with a lander on top. It's actually pretty cool. Cygnus. Actually, guys, that version of Cygnus, see this version right here? I don't call that Cygnus. I call it Bigness. It's Bigness. Bigness. Why? Why is it called Bigness? Now, not if you don't know about Centaur, or not Centaur, Cygnus, right? I mean, you don't know Centaur. Centaur's pretty good too. Check this out. The original Cygnus is tiny. Look, it's small. It's small. It's just two of those plates, right? It's two of those plates. It's a little small boy, right? When they upgraded to Antares 230, they added another segment. That's Bigness. Bigness has the solar panels. Canada mentioned. Actually, it's app or Papayuax. It's upside down, dude. What are you confused? What are you confused, mate? Powak. Adinac. Keg design is goated. It's so cool, man. Yeah, Mike, it's funny that you mentioned that. That guy's cool. I do follow him. Yeah, and just that's some pretty serious fabrication work for being in the garage, man. That's some pretty serious fab work. It's pretty good. Got an interesting question. Did Cygnus ever fly on the shuttle, or was it only on Antares? Well, bigness. Bigness. This is Bigly Cygnus. Bigness. Bigness. So, okay. Has Cygnus ever flown in the shuttle? No, it hasn't. Its ancestors did, though. Cygnus is a pressurized, it's a pressurized segment, and that's about it. So, like, guys, think about this. This is basically an ISS module, right? With a service module attached to the back. That's it. That's why Cygnus just, you guys ever notice that, all these other spacecraft have, like, there's that thing going on with Starliner where they're trying to trace the fault tree, right? There's Dragon, which, had problems on the testing. Anybody ever notice that Cygnus just kind of came into existence and it kind of just exists? Never heard really any problems with it. It's because it's derived from ISS technology. The service module, I'm not sure where that came from, to be 100% real. Don't know. I don't know where that thing came from. But the pressurized segment is derived from the MPLMs. The MPLM is the multi-purpose logistics module. It was how the shuttle resupplied the space station, which is basically, like I said, it's basically a Cygnus with no service module at the back. Now, don't get me wrong. The MPLMs are a little bit wider than Cygnus. This is bigger, but it is derived from that. It's very similar. Keep in mind, this is a smaller diameter, but it is derived from it. Same. I'm pretty sure Thales Alenia makes the pressurized segment. It's made in Italy, believe it or not. But yeah, also just shout out to Cygnus, because Cygnus just exists and it just keeps doing its thing, and it gets contracted to supplies the ISS, actually goes and resupplies the ISS, leaves, refuses to elaborate. I wonder if we could make lunar style Cygnus. I don't see why not. Thales Alenia makes the pressurized segment. Yep. Boy, do I love confidence. Yep. Northrop Grumman. So I actually will shamelessly plug this particular moment in time to say that Northrop Grumman pretty much delivers on every contract that they say they're going to do. Just saying. Actually, guys, if you've been keeping up with it, Northrop Grumman has the B-21 contract. That thing came in actually on time and under budget. Yeah. Just thought I'd let you know. Yeah. Just makes rocket, makes resupply ship, actually resupplies space station, leaves, refuses to elaborate. Okay. Yep. There you go. And actually, yeah, why we watched one launch, NG-21 launched to the ISS like 3 or 4 days ago. It's up there right now. I don't know what you're talking about, Elfish. Congress. Did you see Lundprod's link? If I had seen it, I would have clicked on it, don't you think? All right. I'm warmed up.
Drinking?
I clicked on it now, I'm just saying. I clicked on it now. Not because you reminded me, Ocklets, because I felt like it. I did it now. You had no influence on anything that I just did. Yeah. All right. All right. Let's go. All right. What do we got? Lockheed Martin's water-based lunar architecture this summer. We're going back to the moon. Anyway, sorry. The white paper came out for this architecture. It's all right. Doesn't really address the major issues regarding lunar infrastructure. All right, let me take a look. I've played this game before. Question mark, exclamation point. Rocket Guy, do you think they purposely presented this like a video game? It looks like we're playing No Man's Sky here. Not that I'm complaining. Fission surface power. 250 kilowatt per element continuous power production year-round. Safe, powerful, HALEU fuel. Elite, risk adverse. Sorry, I had to shoot a message out. What did they just stop at? Predicted surface power demand. Power grid connects power generation sources, energy storage, and power loads. Provides fault protections, coordinates power balancing, distributes power loads through surface cables. So, okay. Is this a new game? No, this is from Lockheed Martin showcasing their lunar architecture. I'm gonna tell my kids this is Star Citizen. Vertical solar array, 10 kilowatts of power and full sun deployable 20-meter vertical arrays allows array rotates to follow the sun. Yeah, when you're down on the pole, on the south pole of the moon, yeah, vertical solar arrays make the most sense. I'm gonna tell my kids this is Starfield. Look, Dex, there's their lander. Soft good launch stowed deployed to full size on the surface. 4x higher safety factors than metallic habitats. Up to 40% lower mass than traditional metallic structures. Lunar mobility. That one's broken. That's why we left it on the side of the road. Oh, it's got a little arm on the back. Bro, it's a cherry picker. That's cool. Why is the vid in 360p? Because you are a mean person and people say bad things about you. Ah, yes, utility rover. We call that a trailer on Earth. Beaming power from the ridge down into the crater. That's cool. Why don't we just run a cable? You're in the vacuum. Just run a cable. Why are we beaming power? You have to go up there to put the damn solar panel up, meaning you have to walk up the cliff to put the solar panel there because it's not a lander. What? Cables don't look good when renders. Cables are heavy. Now, cables are heavy, that's a thing, but that's trading mission complexity for mass. Nice are you. I mean, Rocket Guy, yeah. I understand why beaming power would be cool, but also at the same time, it's going to the moon. It's already challenging. You don't need to make it more challenging, right? This isn't like when I play Kerbal and make things more complicated than they need to be on purpose for fun. You're going to the moon. Just send cables. They're not that, I mean, maybe they're 1,500 pounds of, maybe 1,500 pounds of cables is too much. Or 602 kilograms of cables, maybe that's too much. It's a good joke. And I got a chuckle out of the people that got it. So, your rover just drove through one of the pipes. You not gonna lie to you, it just drove through one of the pipes. Am I having a strong... It's intended. Oh, yeah. Hey, wait a minute, fellas. Wait a minute. So you're telling me in this architecture where you beam power wirelessly, you have cables hooking everything else up together? But why? Like, I'm not trying to be a jerk, but also... A new holographic infrastructure tech is cool. Yeah, man. No, okay, like, I'm being a jerk, to be honest with you. This is actually super cool, and I'm happy that companies like Lockheed Martin, people that actually have the money to be able to support an architecture like this, are actually doing it, straight up. It's cool, man. I actually pretty much agree with everything here, despite being a jerk. ISRU needs to be away from plant propulsion. And then that you do not want your fuel depot near where you land. And I noticed that Lockheed was actually smart enough with the landers at the very beginning of the video to put the landers in a lowered crater, like an amphitheater almost landing pad, because of regolith ejecta. So on Earth, like, you have a helicopter come down and land, right? It kicks up a lot of dust, but the dust eventually settles because of our atmosphere, right? And because of gravity. On the moon, no, that doesn't happen. The ejecta can just keep going. It could just keep going for miles in every direction, or kilometers in every direction. There's nothing to stop it, right? It's like if I threw a baseball from center field back to home plate, right, on Earth, and if we had a baseball diamond here, I 1/6 the power. You just do that, and it'll go just as far. If I threw like a full pitch, right, or I threw a ball like at full speed, or I kicked a soccer ball, it would go for miles. Regolith is the same way, because you got to remember, the gases that are getting shot out of a rocket engine are going really, really freaking fast, right? Right? They're going extremely fast, and they hit the ground, equal and opposite reactions. The ground shoots out really, really fast. That's a thing on the moon. You're gonna have to pave a landing site. But even then, you know, there's lunar dust gets everywhere. I mean, you think sand is bad. Lunar regolith is awful. Baby powder. It gets everywhere. So you got to be careful about that stuff. So they were smart about this. And, you know, they're smart having a lunar fuel transfer rover, like a heavy duty truck. This is honestly what we need to be thinking about, to be 100% real. This is the kind of stuff we need to be thinking about if we're going to go to the moon, if we're going to do it seriously. I'm glad somebody's thinking about it. You're going to need a heavy duty rover. You need a light duty, you need trucks. Like, I know, EJ's going to use this as an excuse to talk about trucks. No, you're going to need something like that. Sorry, you are. Actually, you know, a Rivian or a Cybertruck or a Lucid or something, you know, pick your electric truck, right? There's a lot of them at this point. Lucid doesn't make an electric truck, I don't think. A Cybertruck would be great. It'd be great here. The only problem is sitting in that thing with a spacesuit on might be a little bit problematic, but that would actually be a great vehicle for the moon. No joke. I don't think that's a coincidence, fellas, but Elon said it's not related, but also that's definitely not a coincidence. Ford lunar duty when? Yeah, I mean, it's not just like regular light duty trucks. You clearly need something bigger. You clearly need something to be able to move that fuel around, right? And obviously, a light duty rover and a heavy duty rover on the moon are going to be two different things, but you definitely need it. A 1960s Ford truck electric swap on the moon? It would overheat even with the EV, Jesse. The problem is you got to find a way to disperse the heat. You're in the vacuum, so stuff needs radiators on it, like a lot of radiators, or else it'll overheat, or it needs some type of. I was about to say it needs some type of cooling system, but that's not true at all. Would they need a rocket bulldozer up there? I don't actually, Phil. Rocket guy, you know about this. A Tesla Roadster. Yeah, energetic. That's not a bad idea, I think. Can't remember why. um yeah, we're okay. What I was saying is that I'll get down to brass tacks because I want to play KSP because we only have a finite amount of time before Flame Trench. You're gonna need trucks. You're going to need trucks or an SPMT, some type of modular pallet system to be able to move around on the moon. You're gonna have to. Like, you need that. There's no getting around it. You do not want your fuel depot next to your landing pad. Heck, you don't want your fuel depot next to your landing pad down here. Right? That's why pads have the fueling accoutrement a good ways away, right? And even then, those are just tanks. They don't produce fuel near the launch site. I mean, SpaceX is trying to change that, but even Starbase, where they wanted to make the fuel production depot at Sanchez, right? They wanted to do that. I don't think they're doing that anymore, but it's still a good ways away, and you have to truck it there or something. The good thing, though, about this is, like, on the moon, if you find a flat enough spot, you could have ISRU, right? And you could have fuel production, and you could have your pads, and you could just run a pipe. Just run a pipe. Or that's what I mean. Run a pipe. Run cables. Why wouldn't you? The cables are going to be fine. They're going to be great. I mean, actually, now that I'm thinking about it, beaming power is not a bad idea because you're beaming it in the vacuum, which is good. That's great. You might not even need a cable. But I could tend to say that that's making your mission scope more complicated than it needs to be. Maybe wire it first and then do that, right? But you're going to need cables. You're going to need pipes. You could pipe it right to the pad. You're not going to have to, you don't have to worry about too much thermal loss if you insulate the pipe, especially if your ISRU is in a crater. Smart. Less attenuation. Yeah. Hardscape, 37-month resub. Guys, this is what I keep saying. We had that OIG report about SLS yesterday. Are we serious about going back to the moon? Because I'll be honest with you, if we're gonna get back to the moon by the end of this decade, this is the kind of stuff we need to be thinking about now. You need to think about this now. And I'm happy that Lockheed actually is. Oh, don't run that cable over. Okay, run the cable over. Yep, see? Pads manufactured from surface regolith, protective berms shield surface infrastructure from surface ejecta. See? Smart. You're gonna need to do that pretty much at every pad. And in that regard, guys, yeah, you're gonna need a bulldozer. What? You're gonna have people with a shovel up there do that? That'd take forever. You're gonna need a bulldozer. Will additive manufacturing with moon regolith be possible? Good question, Lava. Yes, it's already been pioneered. Believe it or not. Yeah, they're looking at using the lunar regolith as aggregate to make concrete. It's already, and actually being used as additive manufacturing, for additive manufacturing, yeah. Yep, I was at Space Fest, and Saber and I interviewed a company at Space Fest in 2019 that's looking to 3D print lunar structures by basically taking the regolith and making concrete and, 3D printer, and you 3D print the concrete on the moon. Yeah, that's absolutely a thing. That's the kind of stuff we need to be thinking about now. It's smart, dude. That's what I would do. I would... Actually, guys, there is and this is what I was talking about before. Rocket Guy, you know this. I think you're the one that told me about it, if you're here. I think Maston was working on a project to inject slurry into a rocket plume the same way that you do film cooling with a rocket engine. It injects slurry into the rocket plume after the nozzle. Like, it's basically an injector that's on the end of the nozzle, and you actually inject the slurry into the gases. The gases are already hot, and the slurry mixes with the gases, and it hits the lunar regolith and paves it. When the slurry and the hot gases combine with the lunar dust, it'll pave it. It'll make a paved structure for you with the rocket exhaust. Yeah. Aluminum powder to create your own pad as you land. Yeah, dude, that's cool. That is super cool. That's the kind of stuff we need to be thinking about now. We're serious about going back to the moon. You got to think about this stuff, dude. We always give that guy that asked Elon at this International Astronaut Congress in like 2018, the guy that asked about all the crap. But that's the logistics of lunar infrastructure is something you absolutely need to think about. Where's all the poop going? Where's your electrical power coming from? Where are your materials? Are we gonna have a brick? Are we gonna have a brick plant on the moon? Dude, this is the kind of stuff you got to think about right now. It's good stuff. You're gonna need trucks. Like if we're gonna set up our civilization on this celestial body, you need to start building civilization. Are we gonna have lunar trains? Personally, I think lunar trains are a great idea. Maybe not initially, but they're a great idea. We're gonna have paved roads. We're gonna have a bulldozer. How are we gonna pave roads on the moon? We're gonna have an asphalt paver. How are you gonna keep that from overheating? I mean, you need oil to do it, right? The crust partially involves subsurface habitation and mining, EJ. How does it compare to the stuff you just show? I don't know, Kuro. You keep bugging me about the crust and I don't know anything about it. Spin launch makes sense for bulk aggregates to LLO from the surface, than anywhere here, from the lunar surface than anywhere here on Earth. Yep. No, I'm really happy that Lockheed is thinking about this stuff because this is what we need to think about. Oh, mama, is that thing pretty. Even the papers that I've read about taking a Starship HLS and landing it and making it a permanent structure, smart, very smart. That's really good stuff. Actually, if it was up to how I would do this, guys, is I would have a Starship HLS, because with HLS, you don't need to worry about the header tanks at the top, right? It's a lander, right? What I would do is I would have 2 Starship landers, one HLS, right? And then another one that's supposed to be a permanent outpost, right? And you'd land the one that's a permanent outpost, right? And what I would do is this one would be a construction HLS with a robotic manipulator on it with some type of crane, which we already know it kind of has because of the elevator, right? And what I would do is I would have this construction HLS pull the pressurized segment off of the other HLS and set it down on the ground. Think about it for a second. It's not the worst idea, because the whole pressurized segment is going to be, the whole pressurized volume on an HLS is going to be different from the propulsion section, right? So, and we know from the early Starship designs like SN5, SN6, that the avionics is down at the bottom. It's at the top of the methane tank, about halfway up the ship, if I'm understanding this correctly. Now, keep in mind, SpaceX may have moved it. They may have moved it. It's possible. They probably did. But they may, if they didn't, that means you could have a propulsion section for HLS, right? You could have a propulsion section for Starship, something that looks analogous to like SN5, SN6. And now you have, if they're doing butt-to-butt refueling and the guidance system is not part of the pressurized segment, right? There you go. Now you have a reusable lander with no pressurized segment. You have a heavy cargo lander. You take the pressurized segment off, put it in the dust, right? Or put it on a truck and move it somewhere, right? Or better yet, fill it up with inflatable hab modules and a bunch of air. Just, right? See what I'm talking about here? There's many ways you can go with this. I think that would be a great idea. You can't have a normal crane. What? Is it not possible to build underground? Actually, building underground would be preferable, Highland, because of the radiation. Not a lot of people know the moon has an atmosphere, guys. It has an atmosphere. The atmosphere is charged particles of radiation. So if you were out walking around on the moon, right? I mean, keep in mind, these are slightly different types of radiation. You're out walking around on the moon without a suit. Maybe you had a scuba tank on, you'd fry. Similar to like the liquidators at Chernobyl that stared down a graphite reactor that exploded. And they all like burned to death from acute radiation syndrome. Like a couple of weeks later, that's on the moon all the time. You got to be careful. Right? The temps alone wouldn't allow it. We'll come up with a freaking better idea, goalie. Jesus. It's the moon. You can't just say, oh, well, Earth cranes don't work on the moon, so we're not gonna design a crane for the moon. That's bullcrap. Figure it out. Saying we can't figure out a way to make a lever on the freaking moon just because it's too hot. I don't want to know what it's designed to do. I want to know what it can do. Wait, EM launcher? Hold up. Full production draws an average of 350 kilowatt throughout the year. Exit launch velocity of 2.4 kilometers a second, 5,400 miles an hour. They want a railgun launcher. They were cooking with this plan, weren't they? Yeah. I mean, mass drivers on the moon is a great idea. That's pretty awesome infrastructure from Lockheed. Pretty cool. Hey, like I said, they're the ones that are actually thinking about this stuff. That, you know what? I was going to say I'll show it again for space news, but yeah, this is the kind of stuff you have to be thinking about now. And I'm like surprised that NASA isn't like all in our face with this kind of stuff. Like we need you. Look, man, we talked yesterday about like trying to fix SLS and how you would fix it. You got to give it something to do. Give it something to do. Give it and Starship something to do. Right? You have to do that. I think having SLS build Gateway is a great idea. I understand the monetary involvement that might be involved with that. So how about this? How about we take the EUS when it flies and turn it into a wet workshop or even a dry workshop? Put a space station module in the lunar, in the universal stage adapter on SLS Block 1B, and then have that as your space station. You already have propulsion, you already have avionics, right? Do that instead. Why make the power and propulsion element, you know, like, and just take the Halo module and put it on SLS Block 1B and use that as a station module and use Block 1B's EUS as your power and propulsion element. Why wouldn't you do that? I understand why we wouldn't do that, and I know the reasons, but see, like, that would be a much better thing. You got to give SLS something to do. You got to give it context. You got to give it a mission. It has kind of a mission right now, right? I think that would be a great idea. Can they just get the EMALS from General Atomics? I don't see why not. You probably would have to modify it, Manfu, because there's no doubt the electromagnetic assisted launch system on the carriers uses some convection to cool itself. There's no doubt in my mind. Running that in the vacuum would probably make it melt. Hey, Anesthesis, happy Friday. It had many visions, and NASA keeps farming these missions to commercial now. I don't want to know what that noise was. I don't know if you guys heard that or not, but... All right, let's get the sound up. Good. All right. So we figured out some stuff with Dart yesterday. It was actually a kind of a breakthrough thing. So if we look at our tunnel testing with our upgraded Dart yesterday with the double fairing design, we bring that into the wind tunnel, right? And we check the angle of attack curves. Pitching torque when dry, 25,000 at 1,500 meters a second. 25,000 meters at 1,500 meters a second. Take a look. Zero, actually, we were testing minus 45 AOA to positive 45 AOA. Oh, that's 15,000. I got really confused there for a second. I was like, why are you doing this? So I think we moved 90 to 9. All right, if we plot this graph and we figure out where the pitching torque is stable at 0. Yeah, we were able to upgrade it a little bit. We got it to minus 5 degrees with this design by shifting the wings back. What we basically figured out was that this double fairing design is the right thing, but I moved the root part fairing where the body lift information gets imparted on the fuselage. I moved it to the wrong, I moved it too far forward, guys. That's the problem. We moved it too far forward for this shape. So because, here, let me give some context to that. All right, so basically my center of pressure ends up out in front, and because it's out in front, and we have wings underneath here with the grip strips on there that are creating drag and slight amounts of lift, a thing that would naturally want to nose up and flip over actually noses down and tries to flip over that way. So long story short, it ends up being aerodynamically stable when our nose is about 20 degrees pointed down towards the ground. That's not that, you know, like I've seen a lot of things. We watched like Starship re-enter the other, you know, on Flight 3. We've watched it do that. And it re-entered backwards, and I'm fairly confident that that's not what you're supposed to do. I'm pretty sure you want positive angle of attack, not negative. I'm pretty sure negative angle of attack will kill it. What version of KSP you're playing on? The most updated one, Lava Eagle. So Lava, I was thinking about what you said. You're right. The center of pressure out in front would generally want to make the nose go up, but these grip strips down here are pulling the nose down. And when it pulls the nose down, watch what happens to the center of lift. It slowly wants to pull it down, right? See? If it pulls it down even a smidge, look what happens. That moment, that positive momentary force goes negative. That's because we have the wings under the center of mass. If the wings were aligned with my COM, and neutrally pulling, we'd get a gigantic positive pitching moment, right? And maybe that's not the worst idea. Let's put our theory to the test, shall we? So the grip pads are an issue. I wouldn't say they're an issue, it's just not exactly what I want, Jared, right? Like, actually, and the other thing that I noticed is that this version of Dart, Jared, because it likes to basically almost nose to prograde, nose to posigrade, or even a little bit nose down, this thing makes not nearly enough drag. Actually, I think we've made Dart fly too good. To be honest, we need something to induce some drag. So yeah, interesting stuff. So let's go into the wind tunnel, right? So I've been using this mod called Kerbal Wind Tunnel, and what this thing does... Hold on a minute, am I seeing mods? Yeah. Mark, I use... Do you want me to still call you APOC, or is Mark okay? I don't know what you want. What do you want? Let me know. So, I do use mods. They're visual mods. I have Kerbal Construct, which is actually a little bit of a gameplay-inducing mod, and Wind Tunnel and some visual mods. Either works. All right, cool. So, all the parts in KSP that I use, I don't use any modded parts, except if you technically want to count flags. A long time ago, they added flags to KSP, so you can put like decals and stuff on your vehicles, and you can load custom flag textures on it. And of course, we abuse the snot out of that because it's us, right? I still do that, APOC. We still take Kerbal and bring it out for everything that it's worth. But for the most part, these are all the parts that are in KSP 1 and the 2 DLCs. I try to use as many stock parts as I possibly can. And by that, I mean the only things that you see that really are a little weird are my decals and the flags. But the flags are stock parts, so I don't know. If that counts as like super modded or not modded, I don't really care. It's enough to show that you could make, like, if you were following along with me in KSP right now, you could make Dart. You could make it. It just wouldn't have the decals, but you could make this exact thing, no problem. So in Kerbal Wind Tunnel here, which is one of those mods that I was telling you about, we're in our angle of attack curve. So what's angle of attack? Angle of attack in KSP or in aerodynamics is your angle of your fuselage relative to the direction that you're going, or what's called prograde, relative to forward velocity, okay? So when you're in KSP, you have that nav ball, you have the yellow circle. with the hash marks on it, that's where you're going. All right, the yellow circle with the X in it, that's where you came from. That's where you're coming from, right? And the angle of attack is relative to your prograde velocity. In wind tunnel, with the wind tunnel mod, your arrow is going this way. It's going 0 degrees angle of attack is basically the floor. So I'm pretty sure this is somewhat non-dimensional. Rocket Guy, you correct me if I'm wrong. I mean, I'm still kind of struggling with non-dimensional versus dimensional, but so this is basically like if it was flying through the air this way. Like the front of the SPH is where your fan would be, and this is where the SPH is the wind tunnel, right? It's the angle of your wing chord to oncoming airflow, not the fuselage. Yeah, I guess, Nader, that makes sense. My thing is, with spacecraft, sometimes you don't have any wings. Like a pod or something. Oh, geez, now I'm confused. Like Dream Chaser doesn't have any wings. Balls. Gemini parafoil, Grab Shark. Pretty cool idea. KSP challenge for the future. Drive from KSC to the South Pole. No boats, no planes. Everything must be contained on the vehicle. Solar panels, fuel drills, etc. Those are pretty cool challenge, Flykin, but that's a pretty cool challenge, Flykin, but that's better done on a YouTube video. No one wants to sit here for 20 hours driving a vehicle. Believe me, I've tried to do content like that before. Doesn't. No.
Discovery.
Hey, Gravioli, what's up, man? 39 month. It still does aerodynamically since it's a lifting body. There's some sort of wing chords going on there. All right, noted. Anyway, so wings then, okay? So what this is basically saying here, we have pitching torque selected. So pitching torque is what happens when you're flying through the air with none of your control surfaces are moving, okay? What I'm trying to do, and this is what you kind of got to do with a re-entry vehicle, I want my pitching torque to be minimalized from 0 degrees angle of attack to about 45 degrees angle of attack. I want it to be very mitigatable. It's not, I don't think we can make it non-existent, but I'm sure I could figure out a way to do it if we sat here long enough and figured this out. But the reality of the situation is that no vehicle will have 0 pitching torque at any particular moment. That's why we have trim tabs on airplanes. And that's why the space shuttle, for instance, has a body flap. The body flap on the very back of the space shuttle, that little flap that comes off the end that protects the engines, that thing is used as a trim tab for the shuttle. But here's the thing. I don't mind using a little bit of control surface to trim this thing out, or using a little bit of RCS to make it, to minimize our pitching torque up or down, right? However, what we really should be doing is relying on the shape of the vehicle to keep us stable. You don't want your RCS to be compensating for you, right? So for instance, let's look at this current version of Dart. With this current version of Dart, we have 0 degree pitching torque at -5 angle of attack, or -5.59 degrees angle of attack. Basically, the thing wants to fly like this. If I let go of the control surface, it wants to nose down. I don't think I need to say why that's a bad idea during re-entry. I mean, in Kerbal, it's just going to screw up your re-entry trajectory because heating in Kerbal is kind of bush league. It's not like real life. However, in real life, like I said, pitching down, bad, very, very, very bad. Exposing any surface that's not heat shield or thermal protection system. What I was about to say is exposing any surface that's not heat shield or thermal protection system to a leeward flow, so plasma, usually doesn't end well. But the shuttle, for instance, is covered in thermal protection system, right? Even exposing certain types of thermal protection system to leeward flow is a bad idea. Long story short, if the darker black side of the orbiter isn't going first into the leeward side, into the plasma, you're going to have a big problem. Yeah, big problem. Big problems. Yeah. Or if a capsule decides to land pointy side down, bad idea. Very bad idea. You gotta go first with the heat shield, or else you're screwed. Now in Kerbal, you can kind of flip over end. It's kind of forgiving. It's not too bad. It's kind of forgiving because Felipe back in the day abstracted it, because, you know, if it was like real life, no one would get anything through. Nothing would come through re-entry. All of my designs, if the heating was kind of similar to real life, would just IFT3 moment. Yeah. Yeah, exactly. Sometimes even facing your the right part of your spacecraft towards re-entry still doesn't end well. Look at Orion with chunks of the heat shield delaminating during re-entry from Artemis 1. Or IFT3 or even IFT4. Dude, I still am speechless from the footage we got from IFT4. It's
Discovery, go at throttle up.
This footage is some of the gnarliest test footage ever witnessed. It doesn't get better than this. Like I said, we watched this damn thing live. Like, dude, no one has ever gotten footage like this before. No one has ever gotten footage of a leeward side of a vehicle re-entering. That's never been done. Every piece... Now, has there been re-entry footage taken from spacecraft in the past? Yeah. You get some from capsules, there's some from the flight deck of the shuttle, but you can't really see what's going on, right? You just see the windows glow a little bit because they're picking up the trailing edge of your plasma, or your plasma wake here, right? You've never seen anything like this, ever. No one's ever gotten footage like this. The closest thing would be the silts pod on the shuttle, which was a camera that they put on the tail of the shuttle to image the leeward side of the wings, not the part that's getting hot. This is unbelievable. Now, see what happened here? You guys want to hear? So, a little bit on heat shield tolerance, tile tolerances here. You see this whole thing? The chunk of the wing got zapped out because plasma started to permeate through your tiles. That happened because a tile was maybe a half an inch too wide. So these tiles, if you follow Starship development, or if you're a shuttle fan, these tiles have to be shimmed perfectly. The reason why is when this thing comes into land, these tiles absorb a lot of heat. That heat gets conducted into the fuselage of the vehicle, and the fuselage of the vehicle can expand and contract, right? The tiles themselves expand and contract a little bit too. The idea is that during re-entry, the tiles, with that little tiny gap, they expand a little bit and they'll butt up against each other. And it'll create a seal. They'll seal during re-entry, right? But I mean, like I said, you also have to take into account the fuselage of the vehicle is getting hot too because of thermal conductivity, right? Tiles has to be attached to the fuselage somehow, and however your attachment mechanism is, glue, mechanical adhesion, right? Glue like the space shuttle. SpaceX uses a bolt. They use it like a press-on tile or something, but they do have glue in certain areas, right? You have to make it so when the tiles thermally expand, they don't butt up against each other. And if they do, they'll pop like a pog almost, right? This whole thing right here was the result of a tile, their tiles too far away from each other. So a little gap that honestly was probably maybe like 10 millimeter, maybe 12, 13 mil, like a half inch maybe between two tiles, like it was too much. The tiles need to be like 5 millimeters apart. I don't know the exact measurements, right? This one was like 10 mil apart. So we're talking about a gap this big. A gap that big caused a freaking engine block sized hole in the wing. That right there is the result of a gap maybe that big. That's the tolerances we're talking about here on the TPS. You could see it in the re-entry video. The entire fuselage is undulating. Yep. Oh my goodness. Look at, if the plasma finds a way through, it's gonna melt whatever is behind it. And it found a way through. Look, you could see it melting the stringers right there. And what happens is if plasma hits the tiles from the backside, it blows them out completely, which is what you're seeing right there. You guys got to remember, re-entry heating. I mean, it's plasma, right? Re-entry heating, right? It's plasma. So anything that gets near this glowing bit right here is basically subject to the conditions that materials would be subject to with a plasma cutter. With a plasma cutter, like that thing that they use to just zap metal into pieces. That uses the same thing to cut metal in half. Plasma can cut metal really, really well. And right now, physics is taking a plasma cutter to that damn wing. And look, it blew out an entire chunk of the wing. Like, I can't believe that that thing is still working. I think the reason why it's still working is because their plasma flow didn't affect your mechanical attachment points for the wing. So basically, it was still hooked up to the servo, and the front of the wing worked fine. But once again, that meter-sized chunk in the wing was the result of maybe a 10mm gap between two tiles. Maybe, at best. Plasma will find a way. Yep. And like I said, on a little bit of a dark note, that right there, this is poetic, right? The reason why it's poetic is because what got the shuttle? That right there is exactly what happened to the space shuttle in 2003. You know, God rest the souls, right? Like, it sucks. That is exactly what happened, right? And the trajectory that we are on, aerospace puns, the trajectory that we are on, you know, happened directly because of Columbia. I think there's some poetry here, or dark humor or something. I don't think it's dark humor. It's just very interesting, right? Because the trajectory that we're on, you know, going to Constellation and then getting rid of Constellation and then getting rid of the shuttle and then championing commercial crew and stuff, right? And the explosion of the, not literally, or not actually, the explosion of the commercial aerospace sector, like the expansion of it, is because of that. It's because of those events. That's what set us down that course. And it's come full circle, so to speak, here, because Starship had that same problem here. That's exactly what happened to the shuttle. Only the shuttle's wing came off, which really sucks. I mean, it's awful, but that's what happened. And Starship made it through. I think there's some poetry here. I just don't know what it is. Look, see, it heated up the wing so much here. Look at that wing, it's scorched. It heated up so much that it melted the glue off the tiles from the back side. Yeah, Mark, dude, you should see, like, I'm not like one to be like, check out my reaction video. Dude, I was speechless. I had nothing to say. I'm just like, we just witnessed something nuts. Irony is the word you're looking for. Yeah, I guess so, Random. That would probably be a better way to say it. That's crazy, dude. I've never seen anything like that before, ever. I don't think SpaceX even was expecting this. I mean, the next shot here is a picture of the flight controllers at Starbase, right? There's obviously all the technicians and engineers at Hawthorne, right? Look at some of these dudes' faces. They're like, what the hell just happened? Like, this guy can't believe what's going on. I don't blame him. I don't blame him. That is the craziest thing I've ever seen. Look at that dude right there. It's like, that guy is very confused. That's the face that I made. I was like, how are you doing that? How did that even happen? That's wild, man. It's wild stuff. But yeah, that's your tolerances when it comes to thermal protection. Now, in Kerbal, we don't really have to worry about that, right? KSP is very forgiving. Honestly, if Dart tried to re-enter like this without some thermal protection system on the bottom in real life, this shape would just obliterate itself. Plasma would immediately cut the wings off. It would melt the nose, and what was left would just slam into the ground, going at the speed of an ICBM. Yeah, not great, not great. Right? But in Kerbal, I want a realistic re-entry profile because of maneuverability. I want Dart to be able to get back to the runway. And in doing that, we need to maintain a positive angle of attack. One, so I can keep Dart up to be able to steer it through re-entry so I can steer it back to a runway. It's not a capsule that just goes and lands out in the middle of nowhere in the ocean near the launch site and you send a boat out. This thing needs a pinpoint destination. It needs to land, right? So you got to be able to steer this thing during re-entry. That's super freaking important, right? Happy Friday from Rollins, Wyoming. Hey man, today is Friday. So what I'm really looking for is to mitigate my pitching torque, right? What I'm really looking for is to mitigate pitching torque from 0 to 45 at very high speed. That's what the shuttle did. That's what Starship did. I mean, yeah, that's what shuttle did. That's what Starship did. That's what all the pods do this. I mean, pods can actually modulate their pitching torque by rolling the capsule, believe it or not, because of an offset center of gravity. But that's another story. Have you tried giving your wing an angle of incidence with this version of Dart yet? No. Rocket Guy, this version of Dart has basically the stock wings. I'm trying very hard as hard as I can to keep continuity and keep us focused on the heat shield. Or not the heat shield, I'm sorry. I don't know why I said that. I was thinking about pods and heat shields and heat angle modulation from rolling capsules. Angle of attack modulation of heat shields, because we were talking about capsules. Excuse me. No, I haven't. I've tried to maintain continuity to focus on fixing one component at a time. So like when we went to build this yesterday, I built it, like I said, I built it to the specs of Dart, like of the Dart that we used during mission mode, but with the double fuselage hull to try and only change one thing at a time. Try to keep the continuity uniform here in what I'm testing to get better test results. So I haven't changed the AOI on the wings at all. We only really messed around with wing position going back and forth, dude. Have you messed with part highlighting to find a place to improve? No, Wolf, I haven't even gotten that far. No. What we did find yesterday is that with our test results yesterday, we had a model of the vehicle that had the wings forward like this. They were 4 ticks forward. Right? They were 4 ticks forward like that. Center of lift basically on center of mass. And what that got us was not an ideal result, to be 100% real. It was bad. If we apply the same calculations here, this thing will stay neutral, no pitching torque at 10 degrees. Negative 10 degrees. That's bad. That's really bad. I think I had my wings a little bit more forward before, but that, once again, that's another story. What the real big thing is what the component that I've been specifically testing here, okay? The component that I've been specifically testing is the fuselage. I'm trying to mess with the fuselage here. I figured out that the older versions of Dart that had a fairing plate back here and a fairing fuselage that started here and ended at the capsule, right? Had our center of pressure way too far back. All the aerodynamic forces from the fuselage were being imparted on the vehicle here because Kerbal doesn't know any better. So we have to figure out a way with our engineering to tell it that the aerodynamic forces from the fuselage should be imparted at where we roughly think the center of pressure would be. Right? And in this particular case, with this fuselage design, I switched to a double fairing design. So I have one fairing that's buried in here that's facing backwards, right? You can see it right there. It's basically a cone fairing that's facing that way. And then I have another cone fairing that's facing forward. You can see it right there. I have it highlighted, right? And the thing is that in this particular design, the aero forces are imparted on the fairing, on the fairing plates, right? Here and here. Now, if you look at where my fairing plates are, right? One of the fairing plates is basically dead on the center of mass. It's close. That's okay, but the other fairing plate isn't. It's absolutely not. This is putting our center of pressure in front of our center of mass. And because this is all the this is all the stuff that's inside of the fuselage, all the aerodynamics from all the mass that's inside of the fuselage here is being imparted on the vehicle out in front of the center of mass. It's going to create an aerodynamically unstable design. And that's corroborated in our wind tunnel testing. We're proving out our analytical model here. We proved it out yesterday by flying it, and surely enough, it flipped out of control and crashed into the water like a nuclear missile. Yeah, not good. Didn't get anywhere near the runway. So, have you tried giving your wing angle of incidence? Because it almost looks like the wing is pitched up, which could be the reason you're getting the pitch down trim condition. It is pitched up. It's I have anhedral right there, and then we have a positive angle of incidence on the top wing here. So it's anhedral, that's flat, that's positive. The entire bottom wing is positive angle of attack. That's why my center of lift is going this way. Rocket Guide, that was me with an older version of Dart's wing, trying to figure out ways to shift the AOI on the wing a little bit to get my center of lift more in line with my center of mass. That's part of the reason why my center of lift is pointed 5 degrees backwards, because my wings are at 5 degrees AOI. Or part of them are. It's a, you know, we figured out that shifting the entire wing, both, you know, the top the top surfaces and the bottom surfaces, shifting it at 5 degrees, it caused too much. It was too much. But in this particular case, with how we tested this yesterday, right? I mean, once again, so yeah, I haven't really messed with the wings to answer your question. What's going on here is my center of lift has no momentary force over the center of mass, which is what I want. But my center of pressure being applied to the vehicle out in front of the center of mass is basically, if you combined it with center of lift, and you average out those two positions here, I mean, not taking into account the difference in momentary force here. Like, just take the center of pressure and the center of lift. You'd have to figure out how much force the center of pressure is how much moment it's creating on the vehicle through how much force, right? We'd have to figure that out, but that's another story. You basically got to average the position of those two things together if you want an approximate. It's not exact. Remember that. But that puts my overall center of pressure, center of lift, what would it be, a coefficient, I guess? I don't even know if that's a thing. It would put it right out in front of the center of mass, right? And normally, if your center of lift is out in front of the center of mass, it wants to create positive moment. So it basically wants to bring the nose up. That's what we thought. That's what I thought would happen. But the wind tunnel and KSP, as far as I can tell, make this thing want to nose down. And I think the reason why it's doing that is because your wings will create a little bit of drag, right? And the drag force that happens on the wings, right? The drag force that happens on the wings combined with the drag that these grip strips make, because I'm using them as a wing leading edge right there, will actually want to pull the nose down slightly. And what that does is it takes our center of pressure, center of mass, right? That's out in front, or center of pressure, center of lift, being out in front of the center of mass, which should make the vehicle nose up like that. Because the wings create drag, it pulls it down slightly. And that's slightly enough it's enough to make it want to nose down, to make a negative pitch, what's called negative pitch moment. Basically, if the vehicle's just flying, negative pitch moment means the thing wants to nose down. There are forces, aero forces of this thing flying through the air that make it want to nose down. And we proved that in the wind tunnel, and then we went and flew it, and it did exactly what the wind tunnel said, which means this wind tunnel data is, you can trust it. We had an analytical model and we tested it outside of the SPH. The wind tunnel was saying it's going to nose down, and then we went and tested it and it nosed down. That's proving your analysis. It's right. So that means we can trust the wind tunnel data, even though we lost the Dart in the process. But so check this out, guys. How does this work visualized? So my center of lift, watch what happens if I just induce even a couple of degrees nose down. See what I'm talking about? Look, just even a little bit, less than 5 degrees, changed the direction of pull of the, in this case, the center of lift. But you got to remember, this is okay. This would be all right if that was my center of pressure. This would be nice and stable, right? But watch, look. See what I mean? See what I'm talking about there? Because the wings and my grip strips on the wing leading edge create drag, right? It flips it. And then that just creates a compounding negative pitch. Basically, it gets worse over time, and that's what this is. See, that shows up as that right there. Eventually, the wind tunnel's saying eventually this will get down to... It'll get to... We have another zero cross right there. It'll get to minus 41 degrees, and it'll even out. That's when your center of pressure... My center of pressure, which is, once again, you can't see it. The wind tunnel, we have to kind of guess where it is for the most part. The wind tunnel right here has the center of pressure here and my center of lift there. And once again, if you average those forces together, it puts... At basically minus 45 degrees, that's when they'll average out, and that'll be nice and stable. That's when your center of lift and center of pressure are basically pushing right through your center of mass here. But the reason why it was negative pitch moment instead of positive pitch moment is because that fairing right here is way too far out in front. My center of pressure of my fuselage is too far forward. Now, keep in mind, COP can change. And once again, it's abstracted. We don't know when it's going to be coplanar with our center of lift, and we can't really see where it's going to be coplanar with our center of gravity. I know from the wind tunnel testing, right, that if this thing is at minus 10 degrees, it's nice and stable. So, once again, see how the center of lift can move? It can shift. It's shifting front to back right there. Our center of pressure, which once again, we can't really see, our center of pressure is doing the same thing. And when this thing is at minus 10 degrees, right? When it's at minus 10 degrees, that's 0, 5, 10. When it's at minus 10 degrees, our center of lift, center of pressure are going through our center of mass. The averaged position is right there. That's what the wind tunnel says, and we know that the wind tunnel data is right. So we got to figure out a way. We can either stick with this fuselage, right? Stick with this fuselage in its design and kind of go from there. Or we could do what I wanted to do, which is redesign the shape of the fuselage and move the fairings into a position where we know it would be more coplanar with our center of gravity. It should flip direction, the lift vector. That is fine, because on a nose down, the wings with the center of pressure creates a nose up moment. Yep. Does RCS build age show center of pressure? No. So, Rocket Guy, you tell me if my conclusion here is right. We have the wind tunnel data that will tell us more or less where our center of pressure is in any given design. It's not exact, but we know when it's neutral, that means our center of pressure and our center of lift, wherever that might be, is averaged, and that's nice and stable, meaning that this thing will fly perfectly straight like that, right? Rocket Guy, is it possible? And here's EJ's question. This is me learning, guys, so give me a second. That's where I'm at. So now where do we go from here? Is it possible to do wind tunnel testing and create... Do you think I could do this? I mean, I don't see why I wouldn't be able to, but let me ask. Is it possible to use this to, like, I don't know, say take rulers, for instance, right? And plot our center of pressure movement with wind tunnel testing with, like, rulers. Like, I could make this graph and have it kind of behind this thing, right? And we could see where our center of pressure position is, and, like, I'm not sure if we could figure out a way to average that with our center of lift, right? But I mean, it's possible, right? I'm basically trying to see if there's a way that we can visualize this data in the SPH. I'm pretty sure we can, but I'm not 100% sure we can. I could basically make a graph from struts and rulers, right? Like what we did on the jigs when we measure dimensions of a vehicle. I could use that to create a visual graph here, and it could graph our center. voice crack. It could graph where our center of pressure is, I think. I think we'd be able to get it. And now, if we were able to do that, do you think that, I mean, I was about to say, do you think that would be useful? Yeah, it would absolutely be useful. You'd be able to make a super stable design that way. But, is it possible? I think we could, right? I need to watch you using these tools more often. I suck at using these. I suck at getting these things to help me design things. I don't see why not. Use physics-less parts? Antenna? For what, Breen? What am I using? For the graph? Yeah, of course. Cubic octags and struts, dude. Yeah. Now, Rocket Guy, if we were able to get this data, right, and we were able to plot it and kind of superimpose the position of that thing moving with like a cal controller, right? Say we have like we take a circular fuel tank, and if we're looking at it from the side, we have a cal controller basically bound with something like a 3-axis 3D printer that could basically, we mark the cal controller and we take points with the cal controller to average this. So as we move this thing around, right, we could see we could see the movement of our center of pressure, right? And why am I asking this? If we could do that, guys, we could take our center of pressure average and take our center of lift, and we could figure out a way to try to make them coplanar. Basically making a tool that's kind of like my panel tessellator, but with plotting center of mass or center of pressure instead. Hey, Balxy. The only thing to be careful of is any added parts like that will change the plot, since it will take into account where the center of mass changes body drag lift. Who knows? Well, if I put this on a mechanism that attaches to the docking port, we could detach it for a second, right? Plot this, reattach it, do a wind tunnel test, plot it, and then tell it where to attach, and then save the craft file, right? We could get our aero data by just separating the vehicle out and keeping root part on this, right? And if we were able to do that, Rocket Guy, if we were able to get our center of pressure data here, right? And I think we can with this given information. If we were able to do that, I mean, okay, so we have that, we could get that data, I'm pretty sure. So where my mind is going is what do we do with it? What do we do with that? I was about to say average your center of lift and center of pressure, and that might be good enough, right? But what we'd really want here is not just the 3D spatial position of our center of pressure, right? We wouldn't just want that. Okay, great. And even if we did a mean average, right, between those two, that's not going to be 100% accurate, right? Because not momentary force. I mean, I guess it would be momentary force, right? Because the momentary force exerted on these is not static, it's dynamic, right? Rip John McBride. Yeah, that sucks, Donnie. Yeah, rest in peace, man. Tapered nose will make drag. Yeah, the other solution, yeah, James, you said that in 10 minutes ago in chat. The other thing would be is that I don't think we even need that data. We could find a way to fudge it, knowing where a rough center of pressure is, but I contend to say that I think we can get a much higher fidelity simulation here if we use this to plot where COP is. We theoretically could get anything to re-enter accurately, like anything you want. I was just about to ask this as you were bringing it up. Is doing this worth the time and effort to produce the useful information to act on for design changes? Yeah, I'm not sure. The reason why is because we don't have the force. We could pick up the force of our center of pressure, but I can't pick her up. I was about to say I can't pick up the lifting force, but yes, we absolutely can pick up the lifting force. Rocket Guy, I guess my other question here is, if we're doing some hardcore nerd math stuff, is that the way to do it? Is averaging lift force and pitching torque because pitching torque basically gives us our COP for the most part, right? Actually, we'd have to plot pitching torque of the fuselage by itself. It would need to be isolated without the wings. But then putting the wings on, and if we average that against the lifting force, that's not going to work, because that's not accurate. Because our pitching torque is taking into account the wings, is it not? Or does it not take into account wings? You said it might take into account just body lift. Yeah, basically, Rocket Guy, I'm talking myself through making a machine like this in KSP to be able to do this kind of stuff. And would it be worth it? It would only really be worth it if we can get the momentary... Am I saying that right, dude? Momentary force from our center of pressure and center of lift. Basically, figure out what direction the center of pressure is pulling in, right? And how much it's pulling in that direction. Like, it's almost... Like, I almost feel like it is better to use this tool as a simulation. Identify the design difference mark you want, i.e. 0 trim condition, let's say at 5 plus 5 AOA, and choosing a single parameter to change to see if that design change gets you the reference point within a reasonable range. Yeah. I would definitely say that would be better for rapid iteration, and Kerbal favors rapid iteration because it's a video game and not real life. So, Rocket Guy, my other solution here, what my solution, the solution that we came to last night is what I wrote out here. Move the center of pressure of your fuselage backwards so it's more coplanar with your center of mass to get less overall momentary force and movement. Have you checked out Kit Hack? Yeah, Warhawk, I've played Kit Hack on stream before. I played it when it was called Balsa, though. I haven't played it much recently, though. But yeah, it's a good game. I know the developer, dude. He's a good dude. I don't know him very well, but yeah, good buddy of mine. So, Rocket got my next question, I guess, dude, because we're cooking right now. My next question would be, do you think that would be useful as a teaching tool? You know, we're not just thinking about this from an engineering construct. Do you think that would be useful to teach people about this and how it works? Teach people about center of pressure? Because I got to take that into account, right? It's not just getting it to work. It's showing people the process and showing people potentially ways to understand how this stuff works better, right? And, you know, put context to how the real stuff works, right? What the dart doing? Nosing itself down into the ground. I see two big first moves first. Change the fairing placement or change the wing to compensate for the current fuselage design. They're already more forwards, 95. They're too forward. It causes it to nose down. It's stable at minus 10 degrees AOA in that wing configuration there. And yes, regardless of the approach, lots of teaching capabilities. Just finding the center of pressure, which isn't included in the lift reference, would be a huge help in design. Well, Breen, it's abstracted, but I obviously know from this data, and we verified that this data was legit. I obviously know it's out in front of the center of mass somewhere. What I would really need to test is having Dart's fuselage re-enter without any wings and just kind of have it perpendicular to leeward side, or to windward side, right? And then see what the control moment is. But then again, we could test that in the wind tunnel with just the fuselage. Yeah, that's the way forward. Because right now, I know from our wind tunnel data, I know that my center of pressure is way out in front of my center of mass. When you average it with center of lift, it creates a very aerodynamically unstable design, right? So, but I don't know its exact position. Like I said, if I had to guess, it's not much because 10 degrees is not too bad, but it's definitely enough out in front to create, combined with the drag on the underslung wings under a center of gravity, it's designed to, it'll create negative pitch. So once again, it's probably somewhere like right here if I had to guess, because we got to average the position between the two fairings and then the body lift from my fuselage up front. Easy way to find center of pressure at this condition, like you said, trim the vehicle down until you move the zero pitching. Easy way to find this. Like you said, trim the vehicle down until you move, the zero pitching torque to the point of zero AOA. This will be the center of pressure aligned with the center of mass. A COP covers all aerodynamic forces. The stock overlay is just the lifting parts, aka wings. Yeah, and that's the big reason why I don't. I mean, we could make that plotting thing that we had before, but we would have to. The wind tunnel is taking into account the wings, but that isn't. You know what I mean? If this thing was taking into account. If this thing was taking into account your center of pressure, that would be exactly what we're looking for, but it's not. Our non-visualized data is taking that into account, so... Ooh. Is the thing empty? My wind tunnel is with the vehicle dry, so it doesn't... I mean... For our visualization here, yeah, we'd probably want those not empty. Oh man, I really wasn't that far off with this, dudes. We're not far. That was close. So what are we building? I'm working on doing an analytical model for Dart to get it to fly better based off of our flight testing results that corroborated our analytical model from yesterday that basically proved that Dart flies like trash right now. We got to fix some things. Not sure if this is true or not, but the internet say the center of pressure is combined with the center of lift. It is. We know that, Zombie. And it's the little wing icon on the boot left. That is just center of lift, dude. There's no way that takes into account. There's no way that takes into account body lift. That's just your wings. I'm confused. If the center of pressure is in front of the center of mass, then it should backflip, not front flip. The wings being low and creating drag, 95. The wings are creating the drag from the wings are creating a momentary force, which makes it want to nose down just a little, and it flips my center of pressure down, and it forces nose down. Yeah, you're right. This is something I had to talk through with Lava Eagle yesterday, and I couldn't put context to it, but I was sitting in bed last night thinking about this, and that's what's going on. Yeah, Zombie, we know that that is your center of lift of all the wings. That doesn't take into account body lift. Yeah, we knew that. But yeah. Hines. This is why when I use wind tunnel to look at your shuttle, I realized wind tunnel does take all aero forces into account since it showed unstable flight when stock overlay showed stable, confirming the instability I saw during re-entry. Yep. The drag force from my wing leading edges and the wings themselves being tilted up a little bit, 95, and just the natural drag from the wings makes it just want to nose down a little bit, and that positive pitching force that should happen doesn't. That was me. I purposely put that fairing way up there because that's what I thought would happen too. You know, I was like, oh, the fairing's all the way at the back. We need to get it more towards the front. I put it too far forward. We don't. was about to say, we don't want it that far forward, right? But I want it to be more in line with my center of mass. And that's all fine and dandy, but... Now I'm thinking. This is what chat was trying to tell me yesterday. It's the double fuselage, Christian. Yep. Hold up. What's Dart? Dart is my mini shuttle SN15. It's kind of synonymous in function with Dream Chaser or something. Something similar to that. It looks quite good. Oh, it looks great, SN15, but it flies about as good as a bullet. I mean, it flies, it just doesn't fly the way I want, so. Fairing editing would make it easy to recreate the exact shape while moving fairing bases. It'll take me 5 seconds to recreate the fairings 95 regardless of editing or not. It's just shuffling all the other components around while I do it. I'd prefer to do it in game than edit a craft file, you know? Rear drag making downward forces weaker at the top of the aft area, the wings being low. That makes it easier for the nose to go down. Exactly, James. Yeah. Why not panel tessellate the front? Part count. Part count is the biggest reason, dude. If we're gonna have this thing working with a more integrated architecture 95, there's like, if I want to use this in mission mode, it really can't be a lot of parts. So the second we start doing that, the second we start making an aero shell for this thing, yeah, we're gonna have some problems. Does wind tunnel give you the amount of drag force? Yeah. It'll tell you the force of the pitching moment with the way I have it set. You could set it to drag force too if you wanted, or lifting force, or lifting slope. LD, whoa. Whoa. Ooh, that's poopy. That's very poopy. I wish wind tunnel would visualize the actual center of pressure in game. I was trying to figure out a way to see if I could make some a machine like the panel tessellator to plot it for you. Use a Cal controller to plot it based off of our wind tunnel data, and we could see where it moves. Like, create a machine in the SPH to do that for me. But we were wondering, like, even if we had center of pressure here, like, See, now, like, all right. I have a positive angle of incidence on these wings. Now, this is going to look a little bit strange, but keep in mind, this is our test model, so. All right, let's take that underside wing and I'm gonna try to make this wing flat as best as we can. And I want to check something. What is it you're needing? I'm trying to figure something out, Tessa. Give me a second. I don't want to explain it because I don't want to lose my train of thought. Just give me a moment. I need to see something here. I need to see something. So, I want to be sure I'm understanding this because, you know, yeah. Let me see. I'm just trying to make sure the wings are perfectly flat and just absolute snap so I can get kind of a analog test here. So this is a perfectly straight delta wing, and you know what? I'll take the leading edges off. Just actually probably shouldn't have done that because that I'm thinking the leading edges, the drag created by the leading edges is what's causing that downward pitch. But so let's just update the vessel. I need to see something. Update here. Make sure our parameters are set. We were like minus, I think we were using minus 90 to 90. So we have 180 degrees here. So where are we neutral? Removing the angle of incidence from my wings made us fly at 4.87. We're neutral at basically minus 5 down. So we know right here that wherever our center of pressure is, it is aligned with our center of mass. Like it's going straight through it. My guess is that it's this way. Would it be pointing straight up here, guys? No, it's got to be like right here going up because the center of lift is going down. Now, what happens if I move the wings around enough to be aligned? To get my center of lift aligned. Where are we neutral now? 595. And then we're neutral again at 27. What the heck? Huh. So we're neutral at -5, meaning our center of pressure and our center of lift average point is going right through the center of mass right there, for the most part. Am I understanding that right, fellas? It's if we're neutral right here per the wind tunnel tests at -6, give or take, they'd be pointed straight through. Right? The center of lift is coplanar with center of mass if you're looking at the vehicle from the side. Remember, if that slope is positive at 0, you are neutral, not stable. Yeah, man. I got you. So the other point here where we're neutral. Sorry, gotta get the nomenclature right, man. $27. So 5, 10, 15, 20, 25, 30, right there. She's nice and stable right there, interestingly enough. And then we have another point of stability at 87. Yeah. I mean, that you're right, James, in real life. Kerbal doesn't necessarily do that. It's approximated, but yeah. I mean, yeah, Arrow is more complicated than what you see on the screen here in real life. This is actually abstracting a ton of stuff. Yeah, it's neutral at a starship angle, like that. My center of pressure is neutral at, or our pitching torque is neutral at 0. It somehow doesn't feel right. Works for starship, dude. That's way too much, though. See, this is showing us our center of pressure. I just want to confirm, based off of something of what you said, and I read 95 saying, since you are stable and stable with your trim conditions at -5 degrees, the center of pressure is behind your center of lift. So your center of pressure is moving further behind center of mass as you increase AOA to push the nose down. At -5 degrees, your center of pressure is very close to your center of mass. I think center of pressure is the same as center of lift. It is the point of all aerodynamic forces acting on the vehicle, but it may have different vector orientation because of drag. That's what I'm trying to figure out, Rock Guy, the vector orientation. That's what I'm... Yeah. I'm trying to think about, yeah. See, you know what, dude? Just get rid of that. Get rid of that. It's misleading. We need to use this to try and figure out where our moment is going. So if we're neutral, right, that means we're coplanar, right? Am I figuring... Is that correct? You have FAR installed. No, this is messing with Kerbal stock aerodynamics. Understood, sir. Over and out. What's up, Sean? How you doing? I mean, I guess it is Starship's turn to blow up again. No wonder NASA doesn't like using them. NASA doesn't like using it because it's unproven, right? Like, you're not gonna put You're not gonna put people on a vehicle that had half of its wing get torn off through the last re-entry test that it did. Probably need more conclusive data there. Right? Probably should figure that one out. And then over here, we're also neutral. Tie me to the starship and fire me at Mars. I'm ready. The 90-degree trim condition makes sense, hence why aircraft can get into a death spin needing to power out of that condition. Yeah, I got you. But, Raw Guy, just for clarification here, just so me and anybody that's following along understands this, that's neutral, right? Meaning we're coplanar. Any humps in this graph right here is the center of pressure moving about relative to center of mass, right? What information are you looking for? I'm trying to see if we can find a think of a visualization of where our center of pressure is. Jessa, if I could get a center of pressure plot and the velocity, what is it? The vector? What did you call it, Rocket Guy? Sorry, I gotta get my terminology better. This is what I'm trying to work on. Vector orientation. Basically the arrow. If I can figure out where the center of pressure is and the arrow, the way it's pointing, we could get this thing basically perfect. Dessa, before you go down that road, I'm not really looking for mods to do that. I want to see if we can figure it out with what we have. Personally, I would avoid using neutral, since neutral stability is a separate thing. That is a trim condition where your vehicle wants to fly, but it is statically stable. Okay, cool. So at 45 we have 56 kilonewton meters of downward force. If that's the case, my center of pressure is behind, right? How are you in Hat Man? Hey, Dr. Gnome. Right? That's what I'm reading here. And only up here are we out in front, but it's not out in front by very much. This is actually pretty good for what it is, dude. It's not bad. Just bear with me. I know this is messing everything up. Tomahawk Tom, what's up, dude? 41 months. This thing is not going to be able to land. There's no way that's landing, but I'm just trying to kind of find an ideal condition here. You know what? Just get rid of the gear. All right. Update the vessel. Minus 90, 290, Y. Huh. Interesting. So that's pretty close to what I'm looking for, guys. Like here, let's take the plot from 0 to 45. So that line is pretty steep, but look, the overall difference here is next to nothing. Interesting. Isn't the vector angle of the total aerodynamic force just arc10 of the lift to drag ratio? That sounds right, but I'll be 100% real with you, man. Don't know. That sounds right. Yeah, because you're getting into some hard. I know you're getting into trig with this, right? And that's why I'm looking for the vector, right? The vector angle, right? Because I know you're using trig because, right, if the vector angle isn't completely straight up and it's off, you're gonna have to use trig to figure out whatever the it would be arctangent, right? Whatever the loss is, right, relative to the center of mass. Am I in the ballpark here? I mean, I thought it would be a cosine loss, but I mean, arctangent sounds right, but I need to get better at this, dude. This is what I'm talking about, dude. I gotta get better. We have to get good. How goes it? Not bad. Not bad. Some interesting results going on here, for sure. Could I suggest moving the wings back a bit? Bits! So what's the vector, Victor? I don't know, Roger. So with your current config, center of pressure is not in front of the center of mass until 22.5 angle of attack. Let's go minus 45 to 45. COP is in front until 22.5, hence the instability. Very interesting. Love, you said move the wings back a little bit. I moved them back 5 ticks. You know what this looks like? Yep. I knew I'd seen this before somewhere. It's frickin' Von Braun's shuttle. What the heck is that thing? That's what Von Braun wanted to make before the plans changed basically into the Saturn V. He wanted to make a heavy duty, he wanted to make a shuttle, but not like the space shuttle, something completely different. Something like that. So you have your first stage, gigantic wings, second stage, right? And then your third stage. This is actually really smart, dude, because with the second stage, note there's no wings on it, because there doesn't need to be wings on it, because your center of pressure, because this is conic, is way back here. It's way out. Yeah, that actually can counteract your freaking wing. That's really smart, man. Guy knew what he was doing. Yeah, we want this line to be going down. If it's going down, it's better. Or, that's not entirely true. It's better for what we're trying to do in this particular application. There might be an application where you want that line to be going up. You've got to remember, aerospace engineering and any form of engineering, it's all about what you're trying to do. We are trying to be stable at higher angles of attack here, so a downward line is favorable to our stability. Yeah, it's all right, Tessa. You don't need to apologize. It's all good, man. This gives us, I mean, we could figure out where it is. It's just, it's vector. Like, what direction it's going in is harder to ascertain. Not bad. I mean, that's definitely stable. It'll want to just basically iron out right at 0, 0. I noticed Dart's wing is slightly longer. It's not. I've used the same configuration of wings the entire time, 95. It certainly is better. I mean, but our momentary force up here gets to be way too high. It goes off exponentially after... Well, not exponentially. It goes off, like, way more. A slight angle of incidence? How much, dude? You want to try 5? Let's try 5. That made it go negative. So, okay. Hold on. Let me try something stupid. Yeah, the Venture Star. Yeah, its wings are doing that. That's why they're angled down, combined with a lifting body. I've always said that with Venture Star, its wings aren't wings, they're stabilizers. Because the body is the lift. The whole fuselage is the wing. These are stabilizers, right? Oh, that's, who did that? I forget who made that
Discovery,
mod. That guy
go and
watches
throttle
the
up.
stream. It wasn't Theix. Theix made the part vessel hierarchy. MGB. That's MGB's mod. Which is amazing. How would deflecting the flaps upward change the graph now? Well, remember, we're static pitching torque, so it would have to read it as a deploy, but... Yeah, exactly what we thought. All right, now let me check something, bros. Just out of curiosity. Wow. I'm messing with this. I'm just curious. Let's dial in a little bit anhedral to this. I'm just humoring myself here. Dihedral, excuse me. Yeah, with the wings below the center of mass drag, we'll always almost make it pitch down. Yeah, because... Yeah. I mean, Lava Eagle and Rocket, all I'm thinking is that this just makes me respect the shuttle design way more than I already did, because the wings are down in the bottom on that thing, and they got that thing to work. That's it, dude. It's pretty good. Could you put them slightly above it? Yeah, I mean, let me change these back to where they were. Can you imagine? Put the wings up here. Let's see. I mean, that should be super good. That should be exactly what we want. Whoa. So cursed, dude. You're not wrong. Freaking hang glider. Dart the hang glider. It's so bad. I hate it. I hate it so much, dude. I can't. Oh, God. I hate it. Hi. What's up, TJ? How fast do you think SpaceX can get a Dragon 2 to pad with NASA asking them once to get ready to possibility get the astronauts home if they can't use Starliner? They'll use the Crew 9 Dragon, TJ, so pretty fast. It looks big dumb, dude. Yeah. So where my mind is going, fellas, how did the shuttle do it? How does it do it? I mean, clearly I made it work. We've made it work in KSP. So what is it about the shuttle shape that gets it to do that? What is it about the shuttle's wing shape? It's got a very blunt nose. And the long body of it. Okay, well, let's make our nose blunt. All right. The tie striker. Yeah, it kind of does look like that, doesn't it? It's the gradually extending wing. Yeah, it's Delta Wing design, Chris. Yeah. That's pretty blunt. Yeah. Yeah, it's pretty good. Yep. It's my panels. The panels at the front of the shuttle. The panels at the front of Collins are doing exactly what they should. Aerodynamically, they're doing exactly what the real one does, which is super cool. That tells me that Kerbal is pretty damn good at picking up shapes. Interesting. Interdasting. Maybe we should revisit that the arrow shell design, dudes. Maybe we should. I'm just worried about part count, dudes. Let's move them 3 clicks forward. Let's see what happens. Like I said, Kerbal is it's amalgamated, guys. It's not like a perfect aero simulation, but it is good enough to get the point across. Like you can actually learn stuff about real aero from this if you know what you're looking for. We'll move it back 20 centimeters. That's so weird, dude. Oh my god, this is messing with my head. It's messing with me. This is messing with me. That's so strange. Oh my goodness. See, that's so weird, dude. That gives us really nice stability. Or at least something that's uniform and consistent. But the problem is that it's uniform and consistent from -20 to +20. Never pitch past 20 degrees. 95, that's inside of our flight envelope, or what I want for the flight envelope. It's not just, oh, I don't want it to pitch past 20 degrees, or oh, don't pitch it past 20 degrees and try to make do with what you have. That's not how this works, right? You don't want to do something like that. What you want to do is figure out what you need. Figure out what angle attack you need. I don't want to go above 45. From all my shuttle re-entries that I've ever done, we really never go above 45. Heck, with Collins, I don't even go above 30. Right? Now, don't get me wrong. Different vehicles might warrant doing that, but this is a shuttle. I want it to fly similar to Collins because it's a re-entry, a hypersonic re-entry vehicle. Collins for me is like perfect, right? We even checked it in the wind tunnel. It's actually really good. It flies great. You have you're stable at positive angle of attack, like at 30, going really, really fast, which is awesome. Unstable if you nose down at all before, like, 4 degrees. Be honest, what does an internal combustion engine push off of in space without air? Google Translate. Reaction mass? It pushes gases out. The rocket engine is pushing against the gases that it's forcing out at high speed. This is force mass times acceleration equal to opposite reactions. You don't need an atmospheric medium to do that. Bit off topic, but you ever flown your Starship replica through entry? We've done it a couple of times, Pigzig, yeah. Alright, I'm gonna try another weird thing.
Discovery, go at throttle up.
Yep. I mean, Rocket Guy, this is good news and gooder news, I guess. So the idea is that, you had and that I kind of honed in on, I mean, of not making the entire bottom of the fuselage. We had this idea like 5 years ago, dude, like of using wings and panels to make the bottom of the fuselage. That's the way to go. That's the way to go to get it to balance the way you want, to get Kerbal to pick up the right conditions so you can make a proper lifting body. Hey, 2 Paper Notes, 5-month resub. Thank you. Random question. Have you ever tried to build any spacecraft from sci-fi movies? Yeah, I have. But let's not forget about how it flies on a runway approach. Is it flyable at low altitude? Yeah, that's nice and stable at about 5. That's really good, actually. That's... I'm gonna have to make an aeroshell for this, aren't I? Crap. Oh boy. Aeroshell. Yeah. Yeah, Sam. Aeroshells. Are you gonna be on Flame Trench today? Yeah, I'm pretty sure. Let me just double check it. Pretty sure they wanted me on there. My conundrum is trying to design a rocket with this type of craft at the top. Yep. What about panel wing strakes? That's what I'm thinking, Blue. Yeah, okay, so sorry, I needed to... I was checking NSF. I thought that more torque equals more aero forces pushing on the vehicle equals more instability, but I guess I was wrong. You can have more torque pushing on the vehicle, 95, but this is pitching torque. So this is telling you basically, okay, so you ever messed in Kerbal, you've taken a vehicle and you moved it around and you saw the center of lift moving around relative to your center of mass or changing its vector orientation or something. That's what this is showing with the center of pressure for pitching torque. That's what it's showing. It's showing it moving around. It's just in graphical form instead of a visualized format. So Sam, you were wondering what an aeroshell is. You've probably seen this before on stream. And don't get me wrong, darts is not gonna be this complicated, but this is an aeroshell. Does this thing fly? Yeah. Yeah, it flies. It can move 36 tons into space. It's pretty good. It's got a payload bay on the top. "95 Liquid Rocket Guy said, the slope of the line is what is important for stability, because you can read it like this. As the nose pitches up, higher angle of attack, more negative torque is applied, meaning it wants the nose to go back down. Instability is, as the nose pitches up, less negative pitching torque is created, meaning the nose wants to continue to pitch up more. Compounding, and Rocket Guy, if we were flying, that would show up as a compounding pitch rate, so your pitch rate would just keep going up when you nose the craft up, right? That's why rates are so important with vehicles, guys, because, yeah, the rates are telling you this information as the vehicle is flying. That's what the space shuttle would look like if it were anime. I mean, this is based off of a real concept, guys. This is based off of Lockheed's Venture Star. That thing. And the X-33 by proxy. should have flown, dude. I'm sorry. I don't mean to soapbox. That thing should have flown. It's a great idea. Like, not even just great idea. That is an amazing design. That's completely breaking the mold for how we think about flying things around in space. In an ideal world, yeah, and that's what I mean. 95. We have stakeholder expectations. We want that line to look a certain way, and we, instead of just sending it and being okay with it, that's not really how they would do it in real life. They would mess with the shape until the shape does what they want it to do, and then you'd go and fly it to understand that what the vehicle that you made is doing what you want to do. That's aerospace engineering, man. That's how it works. What are you trying? It starts with what are you trying to do? You build something that you think is what you're trying to do. Like you build something you think is right, and then you got to understand what you made to make sure that it is what you're trying to do. Yeah, believe it or not, that is what we're trying to do. Per the wind tunnel test, we would have to flight test it to be sure, but that's what we're trying to do. And I don't know how to feel about that because that looks completely ridiculous. If that's what you're trying to do, 95, yeah. You either love that workflow or you don't. This thing is really controllable. So this thing is really controllable between -30 and +30. It's really good, actually. Very controllable like this. Very controllable at low altitude. Now what you would want to do here is see what, from here, right? You want to configure your control surfaces, right? You'd switch over to pitch input, right? See, that's no good. See, what that's telling me right here is that we don't have enough control authority to go. We don't have enough control authority to go to 28. Or -30 and +30. We don't have enough controls to do that. We aren't making enough deflection. We don't have a big enough control surface to do that. But now you have to find the balance. Do we need to be at +30 during landing? No, absolutely not. Aeroshell upside, you would get your second pilot seat. This is near sea level. Oh, I'm very aware of that. We don't need 30 angle of attack to go to land this thing on the runway. No way. Going back to pitching input here. Yeah, see how this lines off right there, and then it basically does the same thing up there? Let's just go 10 times the force of each and see what it does. Yeah, see? That is my control moment right there. That's where the vehicle is controllable at this altitude going this speed. When your pitch input goes above 100% there and there, you're no good. That's when there's no more deflection there. We can change that by adjusting our authority limiter if we really wanted to. You can adjust the authority limiter, and if I'm understanding this correctly, update the vehicle, do it again, look, our line becomes more, it's wider. We have a wider range here, but look, after a certain angle of deflection, guys, your aero surfaces, if they deflect too much, they stop giving you a moment. They stop being pitch and they start becoming an air brake. See, that's why the line falls off right there on either side. Because pretty much anything past like 25 degrees here is just turning it into an air brake. It's just a speed brake. You get too much deflection. You make too much drag and not enough lift. See, that's what that steep part in the graph is. You fell off. L plus unstable AOA plus crash plus RUD. SMH my head. Take the L. So where we go from here, dudes, is basically where we're going from here is we got to build an aeroshell. So the shape in KSP, especially if you're using panels for tessellation, absolutely matters, which makes me even, like, that's even crazier because we got it right on the shuttle by just copying the actual shuttle's shape, which tells me with enough fidelity, you can get Kerbал's aero model to work like real life. I mean, we basically proved that with Collins, which is crazy to me. That's actually insane. Because I just made the shuttle look like it. You know, I'm trying to make it look like it, and I tried to make it perform, but we got it pretty right. But that's not because I used the data to drive my design. I just copied the actual shuttle's shape and then, you know, made some tweaks here and there to fudge it to get it to fly how I thought, right? And it actually worked. You weren't the first one to do that, yeah. All right. Are there any VODs of you building the shuttle? They should be out there, Christian. Yeah, I built that shuttle in late 2022. That's my 5th generation shuttle, that thing. It flies excellent. And when I say it flies excellent, I mean it flies like trash. I say it flies excellent because it flies like the real one. I made it fly like crap on purpose. But see, I did that by using a combination of panels and wings to do basically what we're trying to do right now. The new Northrop plane caught in the wild. Cool. It looks like the shuttle had a baby with a snowmobile. Yeah. I haven't played the Crust, JP. People keep asking me to. Pretty good, man. It's pretty good. But yeah, you bring the nose down, it starts to get upset with you. I can't believe we got this right. Guys, I'll be honest with you. I was kind of guessed. I'll be honest. I was like, oh yeah, the panels will do it. The panels will do it. I kind of guessed and we got it right. I mean, this isn't me like being some freaking Kerbal like prodigy or something. This is blind squirrel finds a nut. You know what I mean? Like, I'm not gonna sit here and pretend like it isn't. Yeah, this is, I guess, where trial and error design gets you, but But 95, the crazy thing about this, about Collins 5, is that I just cooked that up. I did the panel tessellation in a week. We had that design, I finished that orbiter in a week. And we worked on the stack for another 2 weeks, and it was good. And I cranked it out in less than a month, which is the whole stack, which is... It's crazy. My dream would be to figure out a way to get this reusable. That would be amazing. I would love to do it, but we never really did enough research into the docking hierarchy when you have two boosters touching the ground. I'm so damn proud of this thing, dudes. And it has the provisions to be reusable. We could do it. I put in the provisions to make it reattachable with Kraken Tech to an external tank. It's building out the rest of it. I would love to be able to reuse these, but payload integration would suck. That would be awful. How much would you pay for Windows? $99. It's an incredible offer, but it's true. I just can't afford it. Yeah, we're gonna. I think the way forward is to build a smaller version of this for Dart. But where my mind is going, guys, is I might need to redesign the fuselage again. And I mean, the shuttle's amazing, but it's 600 freaking parts. Remember, if we're gonna use Dart and game. Hello? Purple? Oh. I don't think you need to do all this, just finish the wing shape and panels. Well, yeah, of course. I'm not going to design an aero shell that crazy for Dart. We just need... Okay, so I'm worried about part count. That's all. I'm just worried about part count, Blue. Really don't want Dart to be more than 100 parts, and because if it is that, I mean, you got to remember this is going to go with the integration vehicles, etc., 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 right? I want to keep that as a stakeholder expectation, and I know that building out the aero shell that it needs would probably make this thing maybe 150 parts, and that kind of sucks. So where my mind is going is, well, if we're gonna do that, why don't we Buck is bird. If we're gonna do that, why don't we change the fuselage around to better accommodate the aeroshell. Like, don't design an aeroshell around a fuselage that's not designed for it, right? We could have a disaster in Boca. Yeah, DC-201. That's pretty much what it would end up looking like. The CC-8800 crane jib was accidentally detached from its trolley and swung freely, causing the mast strut to break loose. Great. Yeah, well, at least the crane didn't collapse. No, it's fine where I am. Alright, that's not the craft file that I need. We gotta go into the baseline, not the revision. Give me 1 second. This is the one where I started building out the aeroshell for Dart. Why the wings double thick? I did that to make them look more re-entry-esque, because usually on vehicles that re-enter with wings, you have a thicker wing. I'm not even entirely sure that it needs that O-force, but... What I'm doing right now is debating whether we should switch to this. This would have this has the double cockpit and could have up to, you know, you could have a pilot and a commander, which, I mean, Dart has 1 pilot and then crew behind it. With that, we could up our crew count to 6. Check DM's small project I've been working on. Oh, neat. Cool. That's cool, man. So what I'm thinking about right now, guys, is, you know, I could do either one. We could build out either one. Which one is really what I want? I actually really like the two-seater. It's going to require a larger launch vehicle to launch the two-seater. So I'm not sure if Dart will be the best thing for whatever we're trying to do. This vehicle's more capable. That's not necessarily what we need, right? But it is cool. I do like it. And I did say that the whole purpose of this project was to kind of get back into KSP. I guess it would be an added bonus if we could use it in a future save if we really wanted to. But I'm not really too keen on designing a payload and then designing a vehicle around that payload. That's not really conducive for the game mode rules that I play by, but it would still be cool to do as a project. And seeing this project through, getting the aeroshell figured out would basically give us a workflow for aerodynamic analysis for future Kerbal projects, and that's kind of really what I'm after. I want to be able to use this to figure out, to read this information, figure out exactly what I need to do if I'm trying to make a plane, or I'm trying to make a rocket, or trying to make whatever, a re-entry vehicle, and really use that to basically make what I need to make first time, first try, no problem. Does that make sense, dudes? Let me check NSF. If you're gonna do the two-seater, please make the fuselage longer. It's too thick. I'm taking another few from PC-201 and don't have a forward cockpit. Dang. I'd prefer to do that. I mean, 95, we're going to make this thing longer. Once again, bigger. We're going to need a bigger launch vehicle to launch it, making it more, not useless for mission mode, but more like, okay. There you go, Elf. Join the club, dude. What if you did an F-18 double cockpit with two Mark I cockpits? In line on a spacecraft? I don't know. Nah. Nah, I don't want to do that. Mark II in line. No. No, I don't want to build around this. The Mark II inline, I love this part of the cockpit. I can't stand this. Can't stand that, and I can't stand that. That's not cool. Now, see, that's a cool cockpit, but making that into an aeroshell is, making an aeroshell around that is impossible. I only discuss that every day, Clayton. Make an aeroshell around this. Nah, I'm good. Good, thanks. Excited for Flame Trench later? I'm glad, dude. No need for more crew quarters with the Apollo service mod. Yeah, with the Apollo command module. Hey Biff, what's going on? How's KSP going? It's going all right. We're in some serious into some serious aero analysis with Dart. What we learned is actually not anything we didn't know. Panel tessellation in the front of a re-entry vehicle with wings in the back is a very good way of doing things. It makes the vehicle very manageable. So basically how I made Collins back in the day. But I like I said, I know what's going on, but that getting Collins right and nailing it was blind squirrel finds a nut, dude. Like I had no analytical data to prove that panel design worked except for testing it, and it worked. But now that I have the wind tunnel, yeah, it does corroborate what I was thinking. But yeah, it ain't what you know, it's what you can prove. Make the wings integrated with the fuselage and have it fold out with robotics kappa. Nah, a stakeholder expectation is that this is launched at the top of the vehicle, like how a crewed Dream Chaser would launch, with no fairing, because we still need a launch escape system. Are you still working on Shuttle Sunday plans, or are you busy Sundays? I'm busy this Sunday, Dean. I haven't really talked to NSF to work on it too much, but... I guess the question is, what are you trying to do here? I'm talking myself through it. I want to make this, I'm going to see Dart through, just as a way to get back into KSP. We might not use it, and that kind of sucks. So where my mind is going is that the stretch goal for this is to get something that's within my part count specifications. The other thing, Aqualex, is that I think it's important to get the building chops right, to have a concrete budget. I really don't want Dart to be over 100 parts, because if it's not over 100 parts, that makes it much more likely that we will use it in a mission mode save later. I want to make a good vehicle. Like, Collins is awesome. I love that thing. It's 600 parts. But then again, it does way more than what Dart can do. It's an excellent vehicle. It's way more capable, right? I just want to make sure that I'm not... I think incorporating part count into your stakeholder expectations in the context of my mission mode 2 rule set makes a lot of sense. Can't be too complicated, and that's realistic. That's how the real stuff works, right? How about a hinge wing like Virgin Galactic space plane? Yeah, we could make that work, but that's too complicated. That's too complicated for what I'm trying to do. Do you pick a TIE fighter or an X-wing? I mean, the X-wing is arguably better in every way, shape, or form if it's 1v1 versus a TIE fighter. Why is the title about the desert? Are we launching from there? No, John, we're not. The title didn't update on the YouTube stream. I'm trying to visualize how the panels will work on this. I just got a text saying that I should say hi Weasel on stream. Hello. My niece is watching this. Hello, Weasel. Hello. Well, I'm gonna try to budget the parts accordingly, Uncle X. But yeah, I know for a fact that. So it's where I'm at is, look, I can make an air show. I could make one right now. I mean, this was like 5 minutes of work. What we have right there. It wasn't a lot, right? But here's the thing. It does take a lot of work to dial one in. And is the time dialing it in worth it if I know that the part count's going to exceed? Right? I mean, I suppose it's not that big of a deal. And if we got like Ubio's there as part welder and I part welded not the vehicle together, but like some of the support equipment around the vehicle, then maybe it's not a big deal. You know Polly Shore. What? What? You and Mom. That doesn't exist. I'm so confused. What do you guys? I'm totally. The cockpit needs more windows. All right, whatever. We're just gonna build it. I'll build the thick one. I've decided. Get rid of that. Get rid of that. Dump the panels. First thing would be to find the position of the wings. What do we want our wing shape to look like? Actually, I don't even need any of the jig or anything to make this, so we're just gonna make that piece the root, and it's upside down, which is good. And we can get rid of all that. All right, let's go. Doing it this way allows us to be able to get wind tunnel data here. All right, we're at 15 parts. Let's just dump the wings, and this is the rough shape of what we're looking for, right? So now we go in here like this. Make sure that part's auto-strutted. Make sure that part's auto-strutted. There is a battery on that. That's good. All right, so now, do we want the nose to be tilted down? Yes. I think the nose tilt down at 10 degrees like that is good. Good, good, good. What I need to do now is I need to figure out how the Kerbals EVA out of these seats. So I'm just going to go out on the runway real quick, and we're going to have them EVA. I need to see. Single exit point. Okay, cool. Well, AJ, you learn way more than me in KSP. I think I'm a few thousand hours short. Martin, I have 15,000 hours in KSP. Yeah, been doing this a long time, man. That was not very 154. The crane, Creeper. Yeah, I know. I've seen it. Hang on 1 second, dudes. I lost YouTube chat. Been doing this a long time, and that is in no way sad. Yep. My chat just zonked out. Give me one moment. What's going on? Goalie, it looks like they snapped the piece of that the CC8800. We right here. Yeah, I got you now. Sorry, needed to clear cache and refresh. EJ, SpaceX just posted. Oh no. Nope, nope. I don't want to see the end of that video. Yep, I don't want to see the end of that video. That video, yeah, I have a thing about showing death on stream. If you saw it, you saw it. Yeah, that was definitely catching titties. I think Twitch has a thing about that too. Yeah, they do, Jackal. That's my personal rule. That was I've had that rule since before Twitch clarified that damn rule. I don't understand what SpaceX has posted. They posted about the AX-4 mission smoked. Respectable rule. Yeah, that even if it wasn't a rule on Twitch Doctor Gnome, I still wouldn't do it. It's so screwed up. I have problems, yeah, with profiting off of people dying. Yeah, that's some ethical things there. Oh, look, my phone's ringing again. What's up? Yeah. Yep. Love you. Bye. Remo just asked me if she could have some of the chocolate she brought me back from Europe as a gift. So my gift. She's gonna eat the gift that she gave me. Okay. Illness, let's be real. She gave me that. I knew. We all knew the. Shit of that. Our gift. Yep. It's a gift to you, but also to me. So the chocolate she brought back for herself. Yep. 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 Always expect to share a Toblerone. I don't really have a choice in the matter, Kurlani, I guess. It really was never your chocolate. Yeah, exactly. They don't got to know about it. It could be our gift. No gift will ever be our gift. Ooh, that wasn't very nice. How about you, Sideburns? You want some of this gift? Okay, Master Redesign R2. Get rid of that. Get rid of the update. Updated 8/9/24. Save, overwrite pre-existing. I need to set that as root part, which it's funny because it's upside down. We can get rid of the other shuttles. We'll go forward with this. I'll design the aero shell for this. It'll be easier to design an aero shell around a thicker fuselage. Damn, boy. She's thick, boy. That was a prototype. Get rid of that. Get rid of the flags. Get rid of everything. Okay, cool. Now what I need to do is set this as a... we need to set the docking port. Because we want a docking port on the back, just like previous. I was afraid that was going to happen, but that's why I kept the jigs this time. That's what this thing is. It's a dimensional jig, so I can figure out where everything's home is in the event of this happening. We'll set dimensions, new dimensions for the vehicle. Go. Now move this back to where it lines up. Good. Now put this back over here. See? And now the double fairing looks like one fuselage. That's why I use these struts and cubic octags to make a ruler, so I can get marked positions and stuff. It's basically, the whole thing would be on a jig. That's basically, you know, like, I get it. Real spacecraft aren't made exactly like this, but most spacecraft are made on a jig. They're made like this to make sure that every part finds the right home. A great example would be Dream Chaser. See the jig? I don't know what they were doing, goalie. I don't know crane terminology good enough. See the jig pieces that they make it on? There you go. So I'm just doing that in Kerbal so I can keep my measurements, that's all. And pool noodles, yeah, of course. It's Dart. It's a bigger version of Dart, drummer. So it's not an SSTO, no. Ruler's out of the way. Alright, now we gotta do exactly what we do. So the first thing to do here would be to come up with a wing. We need a wing around our fuselage. I scrapped it because I wasn't sure, 415, but I just became sure with the testing that we just did. Yeah, we had to. Not had to. I think this is the best solution given our expectations for what we want from this vehicle. So, just like I did the top profile curve here, I'm going to use rulers to see if we can figure out the approximate shape of what we want here. Okay. That's what I'm looking for, so rotate that. Out of position. Just leave it down there. Save. Alright, now we gotta come up with something here. So... wings are what we're looking for. How are we gonna do this? So how did I do it on Collins? First thing I did was I made panels. I made a center panel line to bridge the wings together that would be in symmetry. So what kind of panels do we want to use for that? What could we get away with? I think the smallest panel is probably how we would need to do it. Because the next biggest one might be able to get away with it to a certain extent, but when we start to get up here, it's going to have to be smaller. We could move to a smaller triangle from there, save some parts. Okay, so I'm going to assign that to root, right? And then I'm going to move this into position, flip this sucker back up into position, and we're going to try as best as we can to follow the profile line. Now, I wasn't expecting to make an aeroshell for this, so my jig piece is kind of fouling here, but that's okay. Actually, you know, the best way to do this would be to make a strip of panels first and then bend it like you would do a metal bender in real life. Okay, for this last one, I will use a triangle. Yeah, it's a great perk, Christoph, for sure. All right. Leaves us a little bit off the back here, but we could always fill it in with panels or something later. Actually, you know what? I'm going to opt for more angle based off of what we learned from the wind tunnel there. Okay, cool. Now, let's pick our wings. I'm gonna set us to an R3, to the revision 3, and we're going to dump the jig. I don't need it. I only needed it to redesign the shell a little bit. That more or less should be our profile shape. Yeah, that should be pretty much what we're looking for. All right, save that. It's gonna be hard to blend that into wings. All right, well, let's get a wing shape first. Pick the wings that we want to use. I wouldn't mind just using these. This design that we had doubled over. Oh, that's too much. Too much wing. Thanks, Martin. Thanks, man. I appreciate the compliment. Oh, nice, Forge. Cool. I'm not doing space news today, guys, because Flame Trench. We're gonna be on NSF today. So you get a Flame Trench with my buddies Jack, and I think Jack's gonna be there. I think Alex is gonna be there. We'll see who else is gonna be there. I'm using propellers as a ruler. Or helicopter blades. It works. September, drummer. It's gonna happen in September. Okay. That's the right wing position that I'm looking for. Alright, so now how did I do this previously? I made my entire hierarchy off the nose cone for thermal purposes. So what I'm gonna need is a strip of the triangles here. No. Small triangle. Triangle tessellation, no. Small side triangle edge. Might need to bring it back, dudes. Now I know what people are thinking. What the frick? What are you doing? Don't worry about it. Trust me on this one. Just, you can depend on your old boy EJ here, alright? Thanks for the vote of confidence, drummer. I appreciate you. That was sarcasm, in case you were wondering. No, we did wind tunnel testing, and we figured out that panel tessellation is actually really good for re-entry vehicles. It's really good for what you're trying to achieve with stability and stuff. So we tested it with Dart's, the smaller version of Dart's fuselage, here. And then I started messing around with the wings. I messed around with the wings, and we figured out that if we get deflection, if we can make a lot of drag underneath the nose on the front with lowered wings, we can get a very stable design, like the shuttle. The shuttle also makes a ton of drag underneath the nose. The nose is like a flattened pancake. So we got to do the same thing, and that's what we doing. Nope, that's not the right hierarchy. Yep, that's the correct one. That's why I call it calibrated. This has the correct calibration for hierarchy for the panels. Rotate that one in, and you should be able to rotate that one in. Then rotate that one in. That one. I think it's safe to say we probably won't need any more than that. I see you opted for a two-seater Dart. Will you also make the one crew variant, or will you concentrate your efforts on this one? This is based off of what we learned, Rem, from doing testing with the other one. KSP, that's what I'm kind of worried about, dude. Really don't want the part count to be over 100 parts, but here we are. You know, it's gonna be hard to do, but we can get it right. Is a scaled up dart for even better arrow? Lava, yes and no. The way I see it is that this is basically the same thing, give or take some changes, right? So if we're going to design the arrow shell, we might as well design it to have more crew. More mass is only going to make this thing, at least if I'm understanding this right, it should make it fly better. I mean, this has the exact same balance at this point. It's the same shell. Same exact dimensions, same everything. Might as well, right? Because if we're going to do the arrow shell, I actually think it would end up being less parts to balance it around a bigger fuselage. You know, because I'll be able to use bigger parts in certain areas. Aqualex was asking me about that earlier. Unicus, my expectation, sorry, yeah, chat was answering it too, but I figure I'd chime in. Part of the reason why I don't want this thing to be more than 100 parts is because, well, the way I play the game, or the way I like to play the game, I mean, as Drummer said, you know, I like to show what's possible. Like, I really like to push the limits of the game. And part of that is a rule set that I used to play Kerbal by called MM2, Mission Mode 2. In Mission Mode 2, you built everything. Rockets, the trucks to move them around, the VAB, the launch pad, fueling depot, lights, whatever. I played an entire mission mode save and probably did close to 100 launches, and I never used the launch pad. The only reason why my launch pad is upgraded, because mission mode works in career mode. Mission mode 2 is a rule set to play career mode by, right? The reason why I did that is to upgrade the pad so I could get bigger sub-assemblies out, but I never, ever put anything on the pad with a launch clamp and hit the space bar. Never did it once. In the entire save. I probably played the save for 6 months. Hundreds of launches. We had different types of launch pads, crew access arms. In this particular case, it's crew access towers not working. I had, at one point, I had a twin pad complex for my Freedom 7 rocket and the Imahara rocket as well. Yeah, I had 2 launch pads going because I needed 2 launch pad capability for whatever reason. I built a crane, I built a VAB. That's me testing it and it not working. This is all me doing analysis on how stuff loads in KSP, but eventually we got it. We would pick the crane up, we would drive the truck in, pick up a hinged piece at the front of the rocket, and then pick the rocket up. I have better time lapses of it later. And then I'd pick up the second stage off of a truck and do the exact same thing. Then we'd take the fairing. I'd have a docking port on top of the fairing that was attached on a decoupler, and when we would launch the vehicle, that would pop off. And you'd lose it, but yeah, stackable fairings. It's named after Grand Imahara, yeah. When we were doing it, when I built that rocket, I was trying to come up with a name for it, and Grand Imahara passed away. So we named it after him. And then we needed to design a crew vehicle for it. There you go. Reason why I want to keep the part count down on Dart, this was when I was doing initial testing. The reason why I want to keep the part count down on Dart is because Dart needs to be attached to a much larger infrastructure. And it's not that Dart being over 100 parts is a problem. If I have 10 ships, like the VAB, the pad, the fueling vehicle, the trucks, whatever, and every one of them goes over my part count budget, then we end up having like 1,500 parts on the screen. I want to be able to play this with a relatively useful frame rate. The thing is, you know, it's not just Dart, it's the bracket to move it. It's the truck to move it. It's the pad. How many things are on the pad? Does the pad have the launch vehicle on it already? You know, there's a lot of rule sets here, and you got to think about this kind of stuff. So my first pad abort test for Dart did not go well, as you can see there. Nobody was on board. Now, the second one went okay. This validated low altitude flying with the vehicle, which was always, frankly, pretty good. It's just re-entry that blows. The Flame Trench, I love that show. Thanks, Rick. Will you use Kerbal Constructs? I have Kerbal Constructs, Billy Willy. Yeah, I do. I use Kerbal Constructs in KSP to store vehicles, right, that I need, like a recovery vehicle for frame rate purposes. And so to be fair, I didn't use Kerbal Constructs in this mission mode. If we do play again, I absolutely will. This time I want Kerbal Constructs so I can put the launch pad away from the VAB and stuff, so I don't have to worry about a launch pad being rendered every time I go to land something on the runway. I wanted to make sure it was far enough away. But yeah, see, there's the original Dart on Freedom 7. The reason why I built, and once again, the aero problems that we encountered with Dart were because the fairing was calculated, all the aero forces that the fuselage was incurring were being induced on the vehicle back here. The reason why I built it out of a fairing plate is because, well, Dart is a Freedom 7 fairing that's just been modified to look like a space shuttle. Seemed like a good idea at the time. Aerodynamically proved to be an awful idea at the time. Do you think the extra added mass at the front will negate the extra lift drag from the panels? I don't know. Finds there's always a little bit of uncertainty with this. You can't be guaranteed, so I'm trying to do it within the best that I can. When I finish this aeroshell on this upgraded Dart, we'll put it in the tunnel. We'll see what it does. I want to go back to doing this, and I hope you guys would too. Phil, I would love to part weld a lot of the sub-assemblies for the trucks. Part weld the sub-assemblies on the trucks and part weld the structure for my VAB. only make the crane parts of the parts that are different sub-assemblies for this, we could reduce a ton of part count that way. Yeah, I think it's a good idea. And with part welder, I'm pretty sure the crane won't drift as much, but it'll still do it. If we get part welder in for like the launch pad, different fueling components, we part weld certain sub-assemblies like on ground service equipment, yeah, we could be really good. And if I get my launch pad, if I still adhere to my vehicle stakeholder expectations of 100 part count limit, we could potentially throw together some stuff that's integrated quite quickly. There you go. See? That's how I did it. Pick the rocket up, make it go vertical. These are uncrewed launches for Dart. And then, see, I added fins down at the bottom for cross-range capability for boost back for the first stage. And then that was an uncrewed flight right there. But it felt really good putting the entirety of Dart together and getting it into space. That was awesome. Then we figured out that the problems that I'm still trying to fix right now. I stopped working on Dart a little shortly after this because it killed Jeb. Yeah, that was not good. But I managed to get some Dart missions back, which is crazy. I actually got that Dart back and used it again. Yeah, just refueled it, sent it right back to the pad, put new Kerbals in. I eventually developed a crew access structure for Dart, and I had service gantries where you could go and that service gantry right there around the interstage was to repack my chutes because this first stage was small enough to be able to come down on parachutes. I didn't feel like making landing legs for it because it would have screwed up the Delta V of the entire vehicle. But you could see another Dart that flew into space sitting over there on the side of the pad. We're gonna do this again. Now that whole crew access structure, if we welded that sucker up together, well, maybe we'd be looking at like 200 to 300 parts in the scene if we welded certain sub-assemblies together. I don't have any problems doing that now. Now that I mean, we know Kerbal 1 ain't going to be updated again, so. Yep, see, this is inside of the service gantries on my crew structure. Yep, that's getting into Dart right there, ingress hatch. And yeah, the Kerbals could like get in and you could walk around on the pad. I had service elevators and gantries everywhere. Not elevators. I put crew tanks around and then I'd put a crew tank underneath it to save on part count so a Kerbal could get into a lander can down here and then they could get up here and it's an elevator, you know what I mean? That's how I got them to move around, but they could walk anywhere. You could walk all around the thing. And so what happens is the thing sat on panels, actually structural girders, right? But when I needed to move it, I would deploy landing gear. You deploy the landing gear, the landing gear deploying would raise the structure up a little bit. It would get down on the landing gear, and then I could tow it away with a truck. Because the landing gear are unpowered. You don't want to use rover wheels because you're introducing sprung weight into the design, and Kerbal doesn't like sprung weight under load. That's how you make a Kraken drive. See, there it goes. Keep in mind, in this save, I had parts from other crashed vehicles and I kept them around. I actually made a junkyard of broken parts for stuff that we ended up not using. Yeah, see, that Dart mission went okay, but I overshot. So part of my mission mode 2 rule set is that, guess what? You don't land it at the Cape, you ain't getting it back. Or at the Cape. You don't land it at KSC, you ain't getting it back. So I had a center point basically on the VAB. And anything that wasn't basically touching that peninsula around KSC, good. Go and get it. Figure out a way to go and get it. It was a difficult rule, but I ended up making a contra rotating sky crane helicopter. And I actually went and picked the stupid thing up. And then I brought it back. That's the one that just launched. We ended up bringing it back. We rescued the crew, brought it back. I did repair Dart at the junkyard, that's right. Yep. There's me reintegrating Dart after I repaired its nose cone. That's another cool thing that we did with Dart. Every part on Dart, with the exception of like the fairings, the crew tank, anywhere where crew stays, so like wings, thrusters, control surfaces, whatever, nose cone, those are all parts that Kerbals can move around on Kerbin with the Kerbal construction. The Kerbal construction thing from that the developers put in, where you can EVA and Kerbals can actually attach parts to things. Dart was entirely repairable. You could repair it outside of without recovering it, without bringing it back into the VAB. You could repair it. All these parts are parts that you could reattach with Kerbal Engineer. Did you do that with the flags and the mission numbers? Yeah, flags. My flag pack, if you type in !flags, yeah, I have numerical flags so I serialized all my components too. So like just like SpaceX. SpaceX has Falcon 9 booster 1080 or Falcon 9 second stage 20 or 2181, right? I serialized everything, and I serialized the Dart as well. Yeah, we serialized every freaking thing, dude. There we go. We could do that, J-Speed, in the future. I wish I got to see that. My playthrough is so mediocre. Oh, Cobb, come on now. I play Kerbal for a living, dude. Don't compare yourself to me. That's not cool. I want people to see this and go, damn, dude, I want to do that. You know what I mean? Freedom 7 was a good little design, Juicebot. It was entirely purpose-driven. It was entirely purpose-driven. There was no, like, I want to make this because it's cool. That's the best part of mission mode. Because you have accountability, right? You're in career mode, and you're forcing yourself to make all the GSE. You really can't make that complicated of a rocket. You have to have pretty clear stakeholder expectations, right? And because of that, right, it forces you to design something that you need, not something that you want. Yeah, Dart landed in the ocean again because I had re-entry problems with it again. Because, yeah, turns out if you test it and it doesn't work, just saying do it again until you get it right, it's not gonna work. Yep, see, I built all these little trucks and stuff to move the vehicles around, to be able to carry them, to be able to scoop them up, recover them. There's us putting together a second stage for Freedom 7.
And finally, for March of 1989, near normal precipitation, near normal temperatures in March, and above normal precipitation, an active storm track will keep cooking on the East Coast here in March as well. And the storm dates,
Holy words, I will not use that crane. Yeah, Goalie, I'm kind of with you on that one. You fatigued the metal in a way that you induced shear on the crane where shear was not supposed to be. Who knows what else is broken on that thing. Is there videos? I have the collection. Drummer, if you want to link the collection, again, if you're here. But dudes, this is why I'm so anal retentive about Dart can't be over 100 parts. It really can't. And that's gonna be a hard challenge to do, because once again, I want to do this again. I want to do this. I want to get back to doing this. This was the most fun, albeit very stressful, the most fun I've had playing KSP. Building everything. You build out the entire thing. Build out the whole mission. It's really cool. It's a really fun way of playing. If not an extremely hard way of playing. Oh look, that was right before we killed him. Oh no, he survived that one. Pathfinder didn't, though. But you can see that one that I was just towing back in the helicopter. There it is. Just sitting there ready to go. Again, if we need it. Yep, I even drove the Kerbals to the pad with the Astro van. That's the Liberty module, which is a science laboratory. Supposed to be somewhat analogous to Skylab. And I built a space station doing that. She knew. She did it again. Yep, there we go. Dock dart up to that module. That was not part of mission mode. We were trying something. If you know, you know. Yeah, if you know. Okay, that gave it away. that gave it away a little bit. Yep. You guys remember SN9? Well, yeah. This was right around the time it was flying. Yeah. Hard to get that to fly right in KSP. What we realized is that you can't use wings. You can't use wing components. If I was gonna make another starship again, we'd have to make the wings out of panels. Or kind of a hybrid like what we're doing with Dart. It does work though. Do you have any screenshots of your career mode? I personally found it a fun playthrough too. I've been showing you screenshots of it, but I'm not sure that's what you're asking, Daitor. Yeah, I know, Wally. Remember that? Yeah. Panels actuated by a control surface. Yeah, good call. And then I got back to mission mode. That's when I tested Dart's pad abort system again. You could see some reused first stages sitting down there, and then the stage recovery vehicle that we designed. I don't know how I got this thing back to the runway more than once. The thing is a death trap. And then I scaled up Freedom 7's design to Freedom 10, which is a 2.5 meter. And then I made the pad able to launch either one with adapter plates. It could do either one. You could launch 7 or 10. Not a bad shot, huh? So yeah, this is the reason why. That's the reason why I really don't want this to be a lot of parts, because it's going to be working with a much bigger infrastructure. Also, notice that stage has 22-2. Yeah, reused first stage. And then we had this structure called the Dart board. It was the Dart storage facility. Didn't really work too well, but I could get around it with hybrid tech nowadays. And there's Dart with its adapter for Freedom 10. Freedom 10 had a very unconventional way of getting back to the launch site. It's a flyback first stage, believe it or not. Yeah. Yep. It uses a not a toroidal wing, I forget what that's called. Yeah, no, it is a toroidal wing. It's a circular wing. Yeah, it uses a circular wing. Kind of like that French. The Snecma Cleopatra. I think it's pretty much Cleopatra. See? Circular wings. Definitely a thing. Oh, yeah. Works, too. That's where I got the idea. I got the idea from this. I'm like, why don't I just put that around my rocket and then have it fly back? New Glenn has those little winglings on there. Why not do that instead? And I know what people are going to say. Well, the only reason that works is because it's a plane and not a rocket. As long as your center of mass and center of lift are in the right spots, I don't see why it wouldn't work. And then, yeah, these stages would boost back, right? And then instead of doing a entry burn, right? You'd get low enough in the atmosphere, you'd steer it, the wing would generate lift, right? You could level off the booster and then turn the engines on and just land at a runway. Heck, man, you know, nowadays, with what we have with the wind tunnel and stuff, and if I got a little bit dangerous at using KRPC, I don't think we'd even need the jet engines. You could just make it fly back and land. I don't think you'd need them. Yeah, that you're seeing that right. That is upward-facing jet engines and landing gear built into the design. It was tricycle landing gear. There's a third landing gear in the engine section, and it would just land like an airplane. See him over there? I can't believe that actually worked. So stupid. But hey, if it's stupid and it works, it's not stupid. Please make mission mode happen again. I'm working on it. That was an entirely purpose-built thing, dude. That's mission mode. I never would have thought of this unless we absolutely needed a way to save money to get our first stages back. So the reason why I took this picture is because this dart just came back from a mission. Somehow I got it back to the runway, and that's the stage that it launched on right there. Yeah. Oh, there's the dart service. Hello? Anonymous gifter gifted Elon Musk a tier 1 sub. All right. There's the shooting star module for Dart. I did make it. I swear. You know, I knew that wasn't a fever dream. And then we used this architecture to land on the freaking moon, dude. I made a lander, and the lander was derived from my space station modules. It's the space station module with a service module jammed into the back. And that thing, we actually got that. I got that to the... We used Freedom 10 to move stuff to the moon. That's crazy. Like, I didn't think too much of it at the time, but jeepers creepers. Yeah, lunar transfer vehicles. Moving the lander. Using LOR, or EOR rendezvous architecture. Earth orbit rendezvous. So basically, you build the lunar transfer vehicle in low Earth orbit, then you send it out there and they go to the moon and they come back. See, this is a transfer vehicle with a crew compartment on it. And this is a transfer vehicle with the lander. We shouldn't have canceled. We shouldn't have canceled this. This architecture is awesome. Frankly, crazy superior. And this was the mission that got Jeb, not the other one. Yeah. Wait, no, he landed? What? I'm so confused. Wait a minute. He went to the moon and... Don't tell me I got him back from the moon and then... The only other reason I would have launched them up there is to do a long duration mission on the station. Yep. So I got him up there, we got him back from the freaking moon. No, it didn't work that time, Jackal. I did that with workers the other day. See that, fellas? All 3 of those shuttles flew into space and were reused. Dude, we were cooking. We were cooking during the pandemic. It was nuts. I want to get back to doing this, but can you see why I'm like, okay, let me get my feet wet again, because this is hard. This is an these rules are insanely difficult. For the next mission, would the launch vehicles be mostly the same, or will they be different? I don't know, Lava Eagle. I'm not sure I could design better than Freedom 10 given the mission mode construct. Like, it might be convergent design, but sure, we could figure something out. What I personally would like to do is develop new launch vehicles, sure. But developing launch vehicles takes time. That's the problem. Interesting, Aqualex. When Freedom Heavy, my guy, my launch pad architecture didn't support that, dude. We'd have to go with a reaction plate design of like Delta 4 Heavy or Falcon Heavy if we wanted to do something like that. Ironic. They came back too. What the hell? When did I freaking... How many missions did we fly with Dart before I figured out it was... I brought another one back? How many missions did we fly before I figured out the damn thing was a death trap? Nice. One too many, I guess so. Yep. That was when we recovered his plane. I went and sent a truck out, and we used Kerbal Engineer, and we recovered all the parts of the crashed Dart, and then I brought them back. And that's... Damn it. What is that? Bargon, after I killed Jeb, I decided to change the architecture around, and I started... I thought at the time, and I still think this is probably okay. The biggest problem that we had with this thing is... I'll tell you in a second. But what happened after that... So I started testing out SSTOs, X33 based SSTOs, and they kind of work. They're not bad. I just couldn't get all the equipment to work with the SSTO right. Yeah, we successfully made a small sat, single stage to orbit plane, a space plane that's based off of Lockheed's X33. Didn't work then. And then I started building out a transporter erector and pad for it. The thing about this SSTO is that it works excellent. I could never get the pad to work right. And there's a reason why, but yeah. Yeah, see? I made a payload dispenser for this thing. You could configure the payload bay, launch a bunch of satellites, you get your whole thing, you get your whole vehicle back. You never get... Yeah, there it is next to Dart. This was... Well, I had a Dart up there, and I didn't want to have people come back down. I had a crew module and a pilot seat that you could put inside of the payload bay. You could reconfigure it with cranes. You could like I had a horizontal integration facility, and you could pull a payload dispenser out of the SSTO, pick up another crane, put the crew tank in, right, and it could launch 3 Kerbals, a pilot and 2 flight engineers. And then I used that to rescue crew that was stranded because we figured out that Dart was a death trap. I didn't want to risk sending another crew back down and killing another person. So yeah, that's launch vehicle 5. The reason why is because it's the fifth. It was the 5th vehicle that I designed in mission mode. So there was Imahara, Freedom 7, Freedom 10. LV4 was a concept that we never did, and 5 was the SSTO. So I ended up making its own pad. And the idea with this small sat launcher is that we could scale to a much bigger architecture if I make the exact same arrow shell with, these are using smaller panels, right? I can make the exact same arrow shell using the bigger panels and get theoretically the same exact vehicle. And that's what we did. This thing could move 36 tons up into space and come right back down. Problem is, when it's fully fueled, it's 272 tons with nothing in it. With fuel and payload, we're looking at over 2,400 tons. And remember, per my mission mode rules set, you need to make the pad. You need to make the pad reusable. So that was me using a mass simulator for my SSTO. And I made a transporter erector to be able to take this 270-ton vehicle and turn it upright. Absolute monster of a launch vehicle. I mean, the thing was ridiculous when I got it to work. So the thing about this is that the SSTO flies really good. This is what I mean. I was really at the height of my game. I really need to work. Remember, we did this without the wind tunnel. We did this without anything, right? And dude, most of the aero and everything was great. It could launch, it could put payload into space, no problem, right? I mean, it was an absolute beast. It's just the pad never worked right. And I did run into a structural issue with its landing gear. It bottomed, I messed up putting the suspension together, so when it landed on the pad, I tried to land it on the runway a couple of times and it blew up after completing a mission. Turns out that this thing with like 16 shuttle engines on it is a little bit expensive, and remember, I'm in career mode. That launch pad is also extremely expensive. It's a lot of parts, right? But we did get it working. I did get this thing operational. It could side slip, it could slide right through the atmosphere, like exactly what we're talking about, exactly what we're trying to do with DART right now. And you could get it back to the runway after I fixed the structural problem with the landing gear. And then you could tow the thing right back over to the pad and launch it again. I never ended up building out the horizontal integration facility for this vehicle. I never did it because I ran out of money. You see that? In certain scenarios, I didn't build out the structure of this launch box good enough. The launch plate right here, it can't hold up a fully fueled SSTO. It just can't do it. It can't, the robotics, because it turns it upright, right? The robotics were not good enough to be able to hold this thing. I could probably redo it nowadays, and I could probably make it better, but it's just not good enough. So I had a pad explode on me, and I don't know if you look at that top right corner, look at how much money I have. I had to sit here and manually recover every single part to try and recoup my funds. So I started launching the small SSTO again, doing some profitable missions, right? I eventually developed its small pad out with its integration, with an integration facility, a crew access arm, and we were able to launch people, no problem. Got crew missions, science missions operational. That's Bob, Bill, and Val right there. There they are in the crew access arm, right? Would Part Welder have helped? Probably. You know, we got them doing their thing. That's the fueling. You'd have to fuel the SSTO up every time on the pad. So I went back to the small launch vehicle so we could make money, and it works. It works great. The small SSTO actually works awesome. The problem is it only has it has 1 ton payload capacity, 1,000 kilos. You can move 2,200 pounds into space, but you get your whole launch vehicle back. Are you planning to do mission mode again? I wouldn't be telling you about it if I wasn't planning on it. The problem is, Marco, that I need to up my game. I'm rusty. This was all a couple of years ago. I can't just crap this out. I wish I was that good. I gotta relearn, and that's why I'm focusing on Dart. So, I finally built up enough money to start testing the big boy again, and that's what we did. Worked pretty good. In fact, what I was planning on doing is using the big boy to bring that Dart back down. We were going to do that. I was going to have Dart ride piggyback on my SSTO when it came back down, so I could recover that vehicle. That's what I was planning, at least. That is a mission extension vehicle. I launched this payload, and this thing has a claw and some robotics on it, and it actually attached itself to a satellite that ran out of fuel and refueled it and moved its orbit. Yep, mission extension vehicles, MEV. Actually, dudes, I got the small SSTO working pretty dang well. So eventually, I built up enough funds to get this thing working again. Did an operational mission with it. This is its, actually, there it is. That's its payload bay, payload bay loading. I could pull stuff in and out of the payload bay with this crane right here. Got it to launch again and land again. And then the next picture is back to the Freedom 10 architecture. So, what happened here? What happened? I think this thing blew up on the pad. I'm pretty sure it exploded. I had some kind of Kraken strike. So I had to go back to Freedom to get the thing to work correctly, to do some revenue missions, to make more money. So we brought it back. And then I stopped. Yeah. What happened was, guys, I was doing a test. I was doing another mission with one of the SSTOs with payload in it. Turned it up right, fueled it, and Kerbal just couldn't handle the launch, the vehicle. The vehicle's 2,400 tons when it's fully fueled. Couldn't handle it, blew up the pad, blew up the SSTO, and I couldn't recover enough parts to make it work. And I think at that point I'd had enough. At that point I had enough. It's very, very difficult. This is really, really, really hard. Then I took a break. I took a break from KSP. That's why every screenshot after this is just random stuff. I launched this into space and I'm just like, I don't want to build up money anymore. I don't want to do that. At that point, I was like, I just should have kept this. Could have kept this and should have fixed Dart. So I just started doing weird stuff. I built this vehicle about 6 months later in, what, like 2022 or something? This is the K92, and that building this vehicle actually gave me what I needed, gave me the knowledge that I needed to make the pad strong enough. Unfortunately. And then we started messing with sci-fi drives, and that was the end of that. So Me working on Dart right now is unfinished business. It's unfinished business because a couple of years ago, that's what I should have done. I should have done this instead of trying to make the SSTO. What's with the weird tail? Oh, that was just me trying to figure out a profile line. So that is the really long answer as to why I don't want this thing to be over 100 parts. So, yeah, we gotta tweak the arrow shell and then go from there. But guys, we'll work more with Thick Boy Dart here. This is space. I'm in space. Lieutenant Edith gets gifted a sub to Vind. Thank you. So yeah, guys, I started playing Kerbal again to get my building skills back up and to kind of dust off the systems engineering in my head to go back to doing that. That if you stick around over the next couple of weeks, we'll get back into it and I'll start playing by those rules again.
This is
gifted a sub to Chivo Seeker. I want to do that again. But if we do it with Part Welder this time around, yeah, we could really cook. We could really get some good stuff done. And it all, you know, I'm using Dart, which basically was unfinished business from the last time we played MM2 rules. I'm using this as a way to jump back in. Do the curves need to be that smooth? Yes. Should you use slightly larger panels on that profile? I'm probably going to get rid of a lot of these Octolux, but yeah. What I'm thinking is take this row of panels and see what I'm saying? They should be able to fit, and then we could fudge some wings in here into this design. But yeah, that's where we're gonna go. So we'll jump back into it over the next week, month. These mission modes the mission modes save us long-term content, but I want mission mode to tell the story, right? That's what's cool. And I got what I wanted. It just, killing Jeb is not a good story. So we need to fix Dart for Jeb in that old save. And then we'll start a new one. And then we'll probably kill Jeb again. Whatever. Rick, thanks for the bits, dude. But yeah, guys, that's the reason I figure I'd give some context as to why. We're gonna jump headlong into this again next week. I have the itch. The wind tunnel, the wind tunnel gave me what I needed to know about fixing unfinished business. How we doing? Good, Rocket Guy. I started working on the arrow shell, and then people were asking me why my stakeholder expectation was 100 parts, and I showed them mission mode too. I showed them all the screenshots. Yeah, that's it. That's what I got right now. Anyway, guys, I have to get ready for Flame Trench, dudes. We got to get ready for NSF the Flame Trench. It is a podcast that I do about what's going on in the weekly space news cycle. You don't need, if you're watching on Twitch, you don't need to go anywhere. I can pipe their feed right onto here. I'm going to be on there. I do watch chat when we do it. And yeah, it's a pretty good show. Pretty fun. Pretty fun little podcast. After that, I'll be back for Friday Night Racing back here. But yeah, if you want to watch it, I'm doing that in lieu of Space News. But it's at the same time, and we're basically talking about the same stuff. So, what I'm going to do is we're going to spool down the YouTube stream, because over on the YouTube side of things, guys, I want you to go to NSF's Flame Trench. Go watch over there, because watching like 6 chats is not fun. And yeah, we will On Twitch, you don't need to go anywhere. You don't need to go anywhere. So, guys, with that being said, I need to get over there. They need me to test everything out before we start. So I'm going to go AFK for a second. Once again, about a 20-minute intermission. Don't go anywhere. We'll be right back with the start of the flame trench. So see you on the other side. For Kerbal, we're jumping back into this, and I'm going to just ramp up playing more and getting more and more stuff done over the next couple of weeks. I have the itch again. I got it back. I'm really happy that I did, because I was worried that it wouldn't come back after what happened with KSP2. All right. Anyway, I'll see you guys in about 20 minutes for Flame Trench. Stay tuned.